And good morning, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon. I'm a 3D printing variety streamer here on Twitch. Good morning, Hybrid Robotics. Welcome in. And Robert C. Quantum Assembler. What's up? Hope everybody's doing well today. I'm starting off with my morning coffee here. This is, one second, folks. Coffee today is Black Rifle Coffee Fur Missile. It is a medium roast and is an homage slash dedication to our military canine working dog units. Guten Tag, that guy makes. Welcome on in. Hope everyone's doing well this morning. And yes, like I said, I do love my Black Rifle Coffee Company. We also love our Dunkin' here, you know, coffee or die. So, hope everybody is doing well on this Saturday morning. May have got a glimpse of the shirt there, but I'll back up some. We do have the Box Turtle shirt on because we are once again working on a Box Turtle. I like this shirt. I've got another one that's green. My wife loved that one when I was wearing it out at 3D Printtopia because we were up on the upper deck wraparound the arena, and she was like, it was real easy because I could stand up there and spot you because of how like that bright green that shirt is. She goes, you really stood out, so that was awesome. Yeah, Box Turtle for life, folks. With that, we're going to go ahead and get started back on our Box Turtle build. So we're going to jump back, and I love how it forgets what page we were working on. Okay, so we're going to jump back a little bit. So I didn't have all of the skirt pieces printed at the last stream. So, and I didn't have the lanes printed. So we skipped the frame and we just went straight into building the extruders and the respoolers. So as you can see in the picture I put on Twitch and various things, we have all four of our extruders built, and we have all four of our respoolers built. So now all we need to do is put our frame together and then mount our extruders and respoolers, and we will be good to go. Or not good to go, but getting there. So as you can see, I have all four lanes built here, and I did print out the lanes that allowed for the desiccant trays. So this will allow us to put desiccant packs or loose desiccant into the bottom of the trays to help dry out our filament and keep our filament dry. Now that, of course, isn't going to work in an open box design, so I will have to update this to the enclosed version once we get there. I just want to kind of future-proof this particular build. Okay. So with that being said, we're going to need to do a little bit of heat set insert to get started here today. So we'll move some of our pieces up out of the way so we can bring our heat press up here. So how's everybody doing this morning? Hopefully everybody's doing well. I apologize for the coughing. For whatever reason, all of a sudden my throat's getting kind of weird and dry. You will see me sit down throughout the stream. For those of you that are new and or do not know, my left foot here, there we go. This left foot here, I tripped on stream a few weeks ago and I broke that toe. And it's been giving me issues on and off since then. So, yeah. so we need to add a heat press insert to the back of this piece. This is our rear corner piece where the buffer is going to be. So we need to put a heat set insert in here, and this is going to hold the buffer in place. So we'll get that one put in. And then on the bottom of each of our 4 lanes, we'll also need to add some additional heat press inserts. And those will be to hold the extruders in. So let me get these parts out of the way so we'll be able to easily access the bottom sides of these. Doing decent, lots of work. Yeah, lots of work these days. On last stream, we kind of made a little bit of an announcement, and after somebody asked what my plans were for my LLC. So I have established a LLC, a limited liability company, and we're going to be doing some things going into this year. We're working with an artist right now. So there's our heat set insert there. And then on the lanes, each of the lanes is going to have this front one done, and then you have a choice of the back. You can either have them all go straight back, or you can do them so that 2 angle inwards, 2 angle, so these 2 at angle inwards, these 2 at angle inwards, or you could do the 2 straight back and have these 2 angle over. It just depends on you, how you want to do that. So sorry about that quick interruption to the story. So somebody asked what we're going to be doing. I do want to do things like printed forward part kits for Box Turtle and other printers. Somebody asked me if I'm going to do commission builds, and the answer to that is yes. And with commission builds, on like a small printer, it might be okay to ship, but if we're doing a bigger printer, then it needs to either be somewhat local, like I'm willing to drive and meet somebody halfway, or timed right so that I can take it to one of the shows and meet somebody at a show. There's too many things that can happen when you ship a large printer around the country, much less around the world. And there's too many different variables and things that can go wrong. Ask, if you never heard of the Tribent, go over to Steve Builds stream or Steve Builds on YouTube. And there should be, if you do search for Tribent, that was what we basically referred to the Voron Trident that he shipped to, I believe it was Murph 2 years ago. And it did not show up. The shipping placard off the crate was delivered to the show. After several months, they found the crate that the shipping placard went to. It had been dropped and looked like it had been dropped and then pushed around by the forklift. And it was literally bent. Like he had to tear it all the way down, figure out which parts he could salvage, which ones he had to replace, and had to rebuild it for the winter. Do you think you'll ever expand a Box Turtle to have more lanes? Hybrid, I do not plan on expanding the Box Turtle past the 4 lanes. Now, there's a thing called a groupie, okay? It looks very much like a top hat to an A1 or an A1 Mini. which does a 4-into-1 at the nozzle, right? You can use that same thing to take the outputs of 4 box turtles into one to go into a printer. Like you can do a 4-into-1, go into the buffer, and then straight into the printer. So you can get the same thing. So you can daisy chain these together. The reason I don't say make it larger, like a 5, 6, 8 lane, I think it was Maker Milo who did a 5 lane. You can't use the AFC-Lite board. The AFC-Lite board is only designed for 4 motors. So you need something that can do more motors. I know people have built one of these using like an octopus board, right? It's doable. You're completely on your own. The design of this is 4 lanes. I know that, like I said, Maker Milo did a 5 lane. I also know that Armored Turtle himself did a 3 lane. So 3 lane, and believe it or not, this fits well on top of a Micron Plus or Salad Fork or something like that. Okay. So if you're doing 3 lanes, you can still use the AFC-Lite board. You're just not populating that 4th lane's connections. But the AFC-Lite board is only designed for 4 lanes because that was the original base design of this. And the plan was always to be able to daisy chain multiples together to get more colors if that's what the individual intended. And I'll even go one further than that. Think about having 4 of these daisy chained together. And so how do I want to do this? So I'm going to have these outside angled in. The question is whether or not I angle the insides in as well, or if I keep these parallel and just angle the outsides in. I think I'm going to keep the center 2 parallel and just angle the outsides in. Yeah, so that's the thing. I think the best thing to do here is to build it as the standard 4 and daisy chain them together. But then let's think about some of the capabilities. Say we're doing a standard 4-color print. We're in a print farm and we're doing a lot of production work. What does that look like? Well, I could get 4 of these, set them all up with 4 spools of the same color, set those up to do, I'll say like a continuous spool or failover. That way, when, it's basically like a spool pooling type setup. So if lane 1 empties out, it automatically just continues with lane 2. It just loads lane 2 and keeps going when it needs that color. So if you go that mentality, you've got four of these doing a multicolor print. Each one's fully loaded with 4 spools. That helps you out in your production capability. You just keep going. And as a spool empties out, it just moves to the next lane. And once you notice you've got 2 or 3 empty spools at your leisure, you can just go and refill those spools so that you can just keep hitting print, 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 and keep going, right? So that's something that you can look at for production run capability, right? So we've got our heat set insert added to the back here. We've figured out how we're going to do our lanes. We're going to go parallel on these 2 and angled in on these 2. And I almost missed getting one of them here. So let's add the last one that we're going to need here. Hey, good morning, Shrimp Father. Welcome on in. Okay, so there's those four. And this is where it's talking about setting things up. So if you're doing the ones that are no hardware, which are the ones I did, then you've got these built-in strips up front and in the back here. Okay, you got these built-in strips here. Or camera. Placement, camera. Okay, we're going here, pulling back towards me. Okay, now you can see that little tab. If you're doing the one that requires hardware, you're going to be putting more heat sets along here, and these printed pieces will print out separately. Now, I haven't had any warpage on the ones that I do where these are separate pieces. Every time I have warpage on this, and it's just a little bit at the ends here, is when I do the no hardware variant. Now, any warpage that you get here, it's at the extremes, and there's no spool there. There's nothing that's going to mess with it. So it's not going to really mess with your parts or your build. But what we're going to need to do is also come in here and put a heat set insert right up here. That is this heat set right up here, which is going to be used to mount our trigger end stops. So let's get those inserted as well. Now, in the first iteration of the files, these trigger end stops did have a heat set insert. Then we took it out. We were going directly into plastic, and I think there was a couple of people that really didn't like that idea. So they did revert back to mounting these using heat press inserts. I can tell you that the ones that I've built where you go directly into the plastic, I've never had an issue with them, but some people have. Yeah, no worries, Thunder Keys. I'm kind of going off memory some, but also looking at the manual as I go through. This is just one of those mornings where we're talking about various things as well as the build. And Thunder Keys, I don't know how long you've been here, but I've decided I'm going to go straight in the middle and then angle in on the ends versus doing two angles or all straight. Okay. Yeah, seems reasonable. Okay, Quantum Assembler, you're driving home. Be safe. Be safe. I think the box turtle is what we've been looking for overall. Yeah, it seems to fix the problem, and it is it's printer agnostic. It can be made to work on any printer. Good morning, Pez Liz. How are you feeling? Hopefully a little bit better. I know Zombie was feeling like crud the other night on his stream. What, Thursday night? Luckily, I don't want to say luckily, but I jumped in and was able to answer a couple of the questions he was having on his black box build. Yeah, so if you're doing the hardware required here, you'd have these little strips, two small ones in the front and one in the back, that you would have to put heat sets into the part for, or into the lane, and then secure on. It's actually really good, and it allows you to print this on even like a, I think it's a 220 or smaller, or like maybe even a 200 millimeter bed. I'd have to double check the length. But that's why there's a hardware version, is so you'd be able to still print the lanes on a smaller printer like an Ender 3, right? Now we're going to install the D2HW switch and a bearing using an M3x10 socket head screw. And this is threaded into plastic. So I think we're done with our heat sets for now. So I'm going to go ahead and move this off the bench, just because I know me, and something hot dangling there, I'm going to stick my arm on it. Hell, as it is, I have hard enough time grabbing parts that I just put a heat set in, you know, because that's a smart move. Now I'm going to step forward just one thing. Yeah, so it wants you to put in the end stop and get these wires there, and then try and put in 5 ECAS fittings. My suggestion, Thunder Keys, if this hasn't been suggested already, flip those. Because most people are either going to be using a tool like I'm going to try and use, or they're going to be pushing down against something hard to try and get those set in there. Having a end stop with some delicate wires that you can yank and crank on, I'd much rather put the ECAS fittings in first, then do this. Now, the one thing I'm going to suggest is look through the paths and see if there's anything debris-wise in there. And if you feel like you need to, before you do anything, take your 2mm drill that was provided in the kit and just run this through your filament pass in this. Now, I'll say be a little careful, right? Because these are your 1 into 4, so they're not full straight pass. I'm just trying to get any like burr or anything that was hanging down, because once again, this part prints like this, so technically there is an overhang, and I'm just trying to make sure that there's no filament like overhang in the way that would cause us problems. And you're doing that by hand. Do not do that with a, you know, chucking this up into a drill or a screwdriver, because then you will take meat out of here that you're not meant to take. Okay, so I'm going to set these right over here for just a second. I'm going to grab my Knipex out. We're going to need our small one for getting the ECAS fittings prepared, and then the large ones to work on getting them in here a little bit easier. And once again, a little bit easier for show and tell and to keep things from going all over the place. We're going to need 5. So we need 5 for this. We're going to need the other 2 for the turtleneck down the road. So while we're at it, we're just going to go ahead and get all of these set up. Hybrid, this is a pretty easy build. It's a repetitive task in a lot of sense, because the you know, you're doing 4 extruders, you're doing 4 respoolers. So what I tend to do is it says build 1, and then at the end it says now go back and build the other 3. I build all 4 at the same time, and it makes it very much like an assembly line type of setup. Hey, Iconic Fab, how are you doing? Hope you're doing well. Been a while since we've seen you on stream. I see that you've got, what is it, the Stealth Press 1S, I believe it is. which is the latest version of the standard size self press. Now I need to rebuild mine, or do a partial rebuild on mine, I should say, because the the bottom legs of my base have split crosswise, so it kind of wobbles front to back. It's just been well used and well loved since I built it over a year ago. So I just need to, at the very minimum, reprint the lower portion and kind of partially disassemble and reassemble it. So doing great despite a long 6-day work week. Yeah, I try not to do any work on Saturday, or actually weekends. But it depends on what's going on. Like if we have we'll say an event, because once again, I do cybersecurity, so I could be involved in dealing with an event for my company. If that's the case, maybe I'm gonna have to hand press this in at least a little bit to get it started. Then I may have to do some stuff on the weekend, but my preference is not to, not to do stuff on the weekend if I can help it. Oh, yeah, it's just a lot of force, and you can see, I mean, I had to put a lot of force to get these in, depending on your tolerances. And that's not bad. It's just, it requires a lot of force. And that's why I'd rather put these in before putting something delicate like an expensive switch. Because once again, that's not a standard D2F switch that everybody would probably have. So I could have sworn I used this in the past to do these. Guess we're just going to do it the hard way. Yeah. Well, and that's why I would prefer to use my Nipix on these. Now, if you have a vise, you could also use a vise. I mean, I'm sure there are ways to get this done. It's just being cantankerous with me right now because my Nipix are just ever so slightly not fitting. I'm sure if I work on it, I will get a... Yeah, if you can't use force, then use excessive force. Exactly. Close now. You do want to make sure that these are fully seated, because if they're not, you will have issues with loads and unloads. Yeah, there's this geometry. We're just going to have to use that good old force mechanism. All right, 2 down, 2 to go. And like I said, it's just one of those things that the way the part is, it's really no easy way to get in there. Make sure that you use a glove or something, protect your hands. That one went in a little bit easier. That, and these are the metal ones, right? These are the metal ones, and all the other ones I've done have been plastic, and I don't know if they're, well, I'm sure the plastic will give a little bit more and a little easier. Well, you just spelled it correct. Knippix. That is exactly, or wait, Knipex. One P. Knipex. That makes sense. These are flat jaw, or flat face, smooth face, smooth jaw, whatever. They're smooth, so you're not going to mar your part up. Okay. They are various sizes. This is 52 millimeter or 2-inch. We've got a this one doesn't say what size it is. The small one doesn't, but I've got a package that I got from KB3D Chris. It looks like a 40 millimeter 1.5 inch, the 52 millimeter 2-inch, and then of course the smaller size. And these are made in Germany. And like I said, they're very, very nice. I thank Chris every time I pull these out because this was a Christmas gift from KB3D Chris last year. And I know why he did it. He got them for me specifically to aid in the assembly of the black box. And I have used them on just about every other build I have done since then. So they have been great tools to have in the toolbox on the workbench. Yeah, Kinetbex. You cannot, yeah, the quartermaster, or sorry, quartermaster. God, every time I see QU, I think quartermaster. Quantum assembler. You're building this to be enclosed. You plan on doing the same with my box turtle with panels from Happy. I didn't know there were different STLs for some of the parts. I know the enclosed version is beta, but I don't print with my spools in the open at all. Is there a way to get a link to those files? Go to the Discord and ask nicely. That'll be my recommendation. I have not even looked at those files. I know that there's a link on the GitHub to them, and it's an empty folder for me. And I do have permissions on the GitHub, so that tells me that they're working on them in the background, and they have not uploaded them to the GitHub yet. So if I were to look out here, right, I see Box Turtle, the 8-track Raven Alpha, which my understanding is he is going to go back to Raven Alpha, the 8-track cassette, after we're done with Box Turtle. There's the software side, the SC Clipper add-on. Filatector is the little filament sensor. You got TurtleNeck and TurtleNeck, and that's all I'm seeing, right? These are the publicly open. I'd have to sign in to see the other side, and I'm not going to do that on stream. Yeah. Thunder keys. Is it going to be like a separate, like, top hat that's hinged, or that you just lift off? Like, how is that's the part that I'm looking at, is how does that set work? I'm just trying to figure out, like, how onerous is it going to be to convert from one to the other? Oh, I got these out, but they want us to remove our built-in supports here. And the easiest way I've found is just to use a flathead screwdriver, and I just hit it on both sides or all four sides just to basically break it away, and then it pops out. We're going to do the same thing over here on the circle, just kind of give it a slight pry on the four sides, north, south, east, west, whatever, and that should just pop straight out. Okay. Now, I will tell you on these parts, there is this little piece right here. It's kind of hard to tell, but there, you see it right there. There is some printed notches. This is also a print and place support that will give you a notch there. I'm not sure if I'm going to need that right yet. It's more for long-term serviceability to be able to get your wires in and out, especially if you're using something like an MMB, which has that XT30 by XT30 2x2 connector. So we should be good with the 4-pin Molex that we're going to use. And it's going to tell me to go ahead and install my fan. Where's my fan at? It's underneath all the other stuff that I put in here. There it is. Yeah, Thunder Keys is one of the folks in the beta. In fact, he's the one that got me into this beta program. So once again, I send my spouse towards him when she gets mad at me for all the stuff that I'm building and doing. And we want the airflow coming into the printer, right? Normally what we want, or the box turtle. So we want the air coming in. And it looks like it has it with the wire coming out the top towards our power inlet. Wiring diagram. Fans along the bottom. I'm going to turn mine 90 degrees so that the wire's coming out along the edge here. And that's going to allow me the most length, and it's going to be able to keep it down along the bottom edge here so it's out of the way. And we're going to mount this with M3x16 button head cap screws. Yeah, it replaces the extrusion corners with 360 extrusion links. Okay, so if it's doing it that way, then I'm assuming that it's going to have some type of flip up front face then, because otherwise you're not going to be able to get your spools in and out if it just makes the four corners longer. And once again, we're doing this with the printed corners, not the full extrusion corners. It should be relatively easy enough. I'm assuming that those uprights would then come set up for like blind joints then, if I would assume. And this is going to be screwed directly into plastic. And I will tell you that these holes are kind of small and tight. It might be worth your while to either take a screw to it without having the fan there, use a smaller screw that you can get your threads started, or potentially what I'm going to look at doing, which will be to take a 3mm drill bit and very gently, we don't want to go the full length, but we just basically want to open up the very front of the hole so that we can get the screws started easier. probably be better to do with like a an actual drill driver instead of like a screwdriver than a drill. But you need to be very, very careful here that you don't blow out these holes. And once again, I'm just trying to get the initial opening done. So I'm not trying to drill through this, because if I do that with a 3mm drill bit, I just screwed myself, because there's nothing for the screw to then bite into. All I'm doing is maybe a 1/2 millimeter just to open the initial plastic up so that I can line the screws up. You can do the same thing if you have a hand drill. Hand drilling would be we'll say a slower, more delicate process, but you also, like I said, you want to be careful here and don't just blast through it with a drill bit, because then you're not going to be able to screw this in. Once again, all I was doing was opening that plastic up right at the very top of the printed part there, so that I'll be able to get my screws to align and then drop in. And on a part like this, there's a little bit of wiggle room. Like you can see there where I'm wiggling this around, there's a little bit of wiggle room. Don't crank one all the way down. Use this to get all 4 of your screws started, then crank them down. Once you get them started, you can crank them down just about in any order, but you want to get them started in those holes. Then you can tighten things down. Welcome on in, Eagle the Dragon. Hope you're doing well this fine morning. Yeah, I got you there. Yeah, that's why I say, building the lanes for the desiccant now just is more of a preventative thing. Like, you're not going to leave this thing open air and then put desiccant packs in it. It makes 0 sense whatsoever. It's more of, I printed them just to future proof so I don't have to reprint those later on. Is the software for Box Turtle written in Python? Yes. It's Python code. So the AFC-Lite software is Python code. That's why I said you have to have access to the Clipper host in order to do this, which means a standard like Creality K1, K1 Max, you don't until you jailbreak it. Once you jailbreak it, you void your warranty, right? So this will never go on a Bamboo Lab. It just won't. Well, I say never, but yeah, it's not. Even if they can break in and do stuff with the software, it's the hardware side of things, like how they actually daisy chain their AMSs. And I'm pretty sure that's definitely where there's going to be a patent, and I'm pretty sure that they will fight that patent. Okay, on these parts, it prints on the flat like this, which means this is an overhang, and that overhang works out very well. But this would be a long, completely unsupported overhang. So they have these print in place parts. Now, these are the only ones that I've ever had like a rough time trying to get out, and you just need to get in on the corner of one of them and it pops out. They come out easily. You're just not going to be able to pick it out with your finger is kind of where I'm going at here because of the way that the support's designed. Now, when I printed some of these out on the Trident using a box turtle, I had a 0.6 nozzle and apparently I was still over extruding. And these, I wound up reprinting these corners on the bamboo just because I wasn't getting those parts out. They were pretty much part and parcel of that corner piece. So I reprinted them over here on the bamboo. And why are you stopped? That's why. So we've got corner pieces prepped. And now we're going to start assembling our frame. So we're going to start with 2 of our long extrusions. And it doesn't really matter top, bottom, whatever for now. But what we're going to use is this down on our solid surface and the flat against the solid surface. And that's going to help us get things lined up. We're going to use the M5 by 16 button head screws. And I'm also going to move it over here to the edge just to make it easier to come in. I will turn off the, let me grab this. Whoop, not that one. 1 second, folks. This. Move that up there. That way it's out of the way. So what I want to do is be able to come in off of the side here because trying to do it right here, I'm going to be right on my board trying to twist it so I can't get my full motion. Now, in the past, you have seen me, I have put Loctite on these. There's no real force on these. There's no real use for using Loctite on these. So it's up to you if you want to use Loctite or not on these. Just going to start getting this started, and I'm going to do my standard trick, holding these 2 extrusions together with an overlap, and that's going to help the top get lined up with that extrusion. So I'm nice and even across the top. The bottom, you can't do that because there's a jump out here. It will tighten up and be straight. This is an LDO extrusion. If you cut this extrusion yourself, you know, like I have, depending on how well you set up your saw, you may or may not have a 90-degree at the edge here. And, you know, it may skew off. So you may not want to tighten it up all the way until you have everything in here. In fact, this is blue. This is telling you to leave them loose. I tend not to listen, apparently. Now, this shows you sliding it in face up because there's a wire there. I'm going to not do it face up. I'm going to actually start with it face down. We're going to slide in that piece. We'll slide in our center piece with the hub towards the bottom. So the flat is the top. So the hub needs to be facing down the bottom. And then our fan is at the top, and our insert hole for our wires is lined up with our other piece. So there is our frame that we're looking at. So fan at the top, wire inlet at the bottom, hub at the bottom. So this is how we're looking, right? And we're going to put an end over here. Just going to flip this over to make it easy to get the end in from this side. And once again, make sure that your bottoms are lined up and that your tops are lined up on your piece. So the flat top should be where the fan is. And we'll grab 2 more of our M5 by 16 screws. Hey, Glendon, welcome on in. Well, yeah, the shell script helpers, though, are more for the install, right? They're not running when you run macros, right? It's Python, standard G-code macros, and then shell scripts are really for doing the install actions. You need to build your Rook, but cannot afford it. Hey, Bear Grylls, how are you going? Are those corners not fitted wrong? Well, we're going to double check real fast. So looking at it here, yeah, they are. Good catch. They are 100% backwards. See that, but we would have checked. We would have done a sanity check. That's what we were getting ready to do. You guys are gonna make me do this part here where I am gonna have to figure out how to keep that wire out of the way as we flip this over so that it sits flat still. There we go. So once again, top at the top, bottom at the bottom. The bottom has the little foot piece at it. The top is nice and flushed at 90. We'll get that up there. And yeah, I promise you, I would have caught that eventually. Hey, Layers with Lily, welcome on in. Layers with Lily is another Twitch streamer, or actually, I'm not sure. Yeah, you stream on Twitch as well, right? I know you stream and post on YouTube. But yeah, she does some great things. She has some great tutorials on designing files and stuff, and designing prints, and I believe, and you can do some things in the slicer as well. She's got a lot of good tips and tricks. We'll just leave it at that. All right, so we fix this one. We'll turn this around. We will undo our error on this side and fix it. Just a baby streamer. Yeah, I promise you I will do some shout outs here. I really need to get a mod. If there was only somebody that was here all the time on the streams that mods other streams that would be willing to be a mod. Who is a super duper awesome person in their own right. Do I plan to do 6 hours again today? Well, Lily, I will tell you this. My Saturday streams do tend to run long unless unless there is a very important Clemson Tiger football game going on, which there isn't right now because bowl games haven't started, and I'm not sure what bowl we're playing in. So yeah, we'll be going, well, I say that, unless there's some other mitigating reason, family, what have you. Saturdays, I tend to go long, and Jesus Louises, Luke. I got it going in the, well, the corner is cornering right, but I just did it like vertically upside down now. Oh, yeah, yeah. Good thing these screws are, you know, easy to put in and take off and put in and take off. So we're going to take this, flip it around like that, so that the flat is against the table and the top is facing me, which would be the top of this part. But yeah, Saturdays are normally my long stream. Normally Tuesdays and Thursdays are shorter streams, though I have done some long streams during the week. I think not too long ago I streamed on a weekday until like midnight because we were just building and going and having a good time. And next thing I know, I was like, holy wow, wait, Big Jano just raided into me. What is that? Because I normally raid into him. Okay, so after a lot, we now have our corner piece going in the right direction. So the end, or the side will go this way. Fan at the top, electronics wiring going in at the bottom, hub at the bottom, and the other corner piece also going in the same and right direction as that. So a side or the rear is good. Okay. Okay. Now it wants me to flip this over, and we're going to take our hub. We're going to stop here, and we're going to jump back a couple of seconds here because we do need to put our, I forgot to jump back after we did our ECAS fittings and put our last end stop wire in. So we're going to need our hub, the D2 HWC201H micro switch, one of our small bearings, and an M3x10 socket head screw. 8s, 16s, what do we do with the 10s? M3x10s, here we go. One of these, we're going to need a bearing. Got that bearing over there. And I will say that this particular size bag is pretty good size to keep. I've got a plethora of these, so I will throw this one away. But keep these bags. You never know when you can reuse them for things, whether it's small bits and bobs or if you start selling yourself. Okay, so that came out bad. So if you start selling, you can reuse them. So in this slot here, you'll see that it looks kind of like an offset T. The T points up here will be slots for the side screws on the D2HF. And down in there, you can't tell because I don't have good lighting here. There is a slot going in the same direction for this little bearing that we're going to put in. So we're going to drop that bearing in there. And now you should be able to, I should be able to see, yeah, the reflection of the bearing in there. And when we go to put our thing in here, you'll notice that there are the screws that are going to pop up, and then there's your plunger. The plunger is going where the bearing's at. Make sure it's pushed in all the way. And now your M3x10 is going to be going through the backside of this end stop switch and thread into plastic. and that's going to hold it in place. So because we're threading into plastic, no ugga-duggas, just cinch it up. You can't find Lee Marie 3D on Twitch. So you're not going to find Lee Marie on Twitch. Lee Marie 3D doesn't have a channel on Switch. It's, oh goodness, it's Print and Play Kyla's Way. I believe somebody, yeah, they're a YouTube channel, but it's his wife that had, there you go, Print and Play Kyla's Way. There you go, Thunder Keys. Thank you. We're going to shout out. Yeah, layers with Lily. We're going to do a shout out for that Pez Liz person because Liz is awesome. We could also do a shout out for Glendon. Glendon's another streamer. Thank you, Mrs. Dragon. And the thank you to Mrs. Dragon was she just brought us our Duncan. Yeah. So we figured it out that she doesn't have to get up and get out when it's really, really cold. She can wait just a little bit. And that way it gives me a chance to get through my first cup of coffee before she comes in with the second round. And what she'll do is she'll pour it into a Yeti mug so it'll stay warm, and then this will be the dregs that doesn't fit in the Yeti mug. She is awesome. I am so spoiled. I am so spoiled. But yeah, it's Print and Play Kylie's Way, or Kylie. I can never remember the pronunciation. Okay, so we got our end-stop installed. And now this is going to get installed straight through the back. Now, because we have our ECAS fitting here, we may have to just lift this up a little tiny bit. And I just want to say, I'm glad that they switched to this design. Okay. And I say that for certain reasons, because this just drops in, well, sort of drops in. It can be pushed in, maybe. No, it's the 4 into the 1. There we go. 4 into 1 that way. So it just drops in. In the older designs, it slid into the skirt piece from the top. And when it did that, that means you have to take the top rail if you ever have to do anything to this particular part. So this is another, we'll say, quality of life maintenance thing that they did that's really nice. So this just slides down in there, and we're going to use an M3 by 10 to secure that as well. Oh, thanks, Hybrid. I just see Chewy's here. Hey, Chewy. Yeah, I am definitely spoiled. She does spoil me. She has now been to all 3 of the US shows with us, and she's gotten to know you guys, so that's been real nice, and you all have got to meet her, and you did the typical and embraced her wholeheartedly, which is really great. That means she lets me come out and play. So here's our hub now with our 1 exit port and our 4 inlets on the inside, and here's our wiring that's going to come over to our thing. Yeah, that thing. The wiring that'll come over to our AFC-Lite board. All right, now we need to get started on the other side. So we'll grab our other 2 long extrusions. No, not the filament on the floor. What do you mean that guy makes? Are you talking about all the filament over here? For the most part, all the filament is now off the floor over here and is on the shelf. So I have like ABS, PLA, more ABS, ASA stuff. There is filament in the poly dry boxes. And then I've got 2 Sunlu dryers that are just sitting here. I'll probably give them away. I've got another poly dry dryer and box over here, so I'll have 2 dryers. But yeah, I've got filament all over the floor here. This is all PLA. Then I've got some ABS over here. Yeah, it's just, yeah. I'm a mess. How about we just put it that way? Okay, so flat, once again, against the table. We're doing it with the foot facing away, the top facing to me. We're going to do our M5 by 16s again. And God's honest truth, these don't need to be 16s. We can get away with 10s and 12s. It's more of the 16 is going to go in further and it'll help. It helps make it rigid, but once again, this doesn't need to be rigid, right? And these are, once again, going in. We're just starting to snug them up. We're not cranking on them. This is the one room that Mrs. Dragon doesn't touch. This is the one room Mrs. Dragon is afraid to come up into. Like, she comes up, gives me my coffee, shakes her head, and leaves again. And then when I go downstairs, she'll tell me, we really need to clean up your office and your studio. Okay, now we're going to put in our 2 front pieces. Now, we did have a print blemish, right? It's in the top corner. I could hide this. Nobody's really going to see it from the front. Like, you'd have to look. But this is the front. So we'll slide that one in. And when you want to make sure that it sticks and that you don't have things like that, that's a layer of Vision Miner Nano Adhesive. So if anybody wants to do a Bang Vision Miner, it will come up with a link to my affiliate page if you want to get some of that. This, I tell you, works really, really well. Parts come right off of it. Technically, it says when you're doing high temp parts like ABS, ASA, polycarbonate, whatever, that you want to apply every single time. I normally don't. PLA, I think it says you can get like 20 or 30 prints out. I find that I get a lot more usage out of it than that. It just all depends on what you're printing. So there you go. Thank you, Chewy. Okay, now it's going to tell us to put the other side on. And to make it easier, I'm going to flip that around. Top, lay it flat so it goes that way. So hopefully we get this right this time and I don't do another bonehead thing. We will, we should be able to tighten this up fully now. So we'll get this one in. Once again, I'm trying to make sure that it stays lined up with the top. Oh, yes, I really do need to clean up my office. We are talking about it. There is conversation happening. There is a lot of room, I will say. There's a lot of room right downstairs in the garage. Or better yet, let me say this. The garage is just as bad as this. It looks like somebody threw a grenade in it. There's stuff everywhere. The stuff everywhere happens to be parts for an airplane that I have decided that I'm not going to continue and finish out, which means I need to sell the airplane project. Once I get that sold, one, it's base income for the business, and then two, we can move some of this stuff. Well, we'll have to do some work in the garage to control it some, but it's right below me. I can add more power down there. We can set some things up a little bit nicer for the print side, right? And that'll clean some of the stuff up out of here because we'll have plenty of room to do things like that. But yeah, we're talking. You're rebuilding the Underwire, got the Nighthawk board and an eddy probe. Anything else you can think of I'm missing? Well, no. I know I've got an eddy board, so when we go to do the Filametrix swap on this, we're going to do just like we did on the other 2.4. We're going to build the Filametrix for this, and when we're putting it back together, we're going to swap from the SB2209 to the Nighthawk board on this. And of course, this has got CNC taps, so I'm not going to worry about that. But I did pick up an eddy coil that I want to try and add to one of the Underwires before I think the two Underwires, they've been sitting down in the front room. I need to bring them out, work on it, not work on them, bring them out, wipe them down, blow the dust off of them, get them up, get them updated, printing again, and then those will go up for sale. But my overall plan for the business, I know we started to talk about this earlier, is like PIF parts for Vorons or any of the other builds. Box Turtle as well. I'll be more than happy to print parts for those. And as well as commission builds for printers. If they're bigger printers like, these things over here, the larger Vorons and stuff, I would really be looking at local delivery. By local, I mean, I'm willing to drive 2 hours my side if you want to meet me. So that gives you like a 4 to 5 hour radius of my location, or timed so that I can bring it to a show and you can pick it up at a show. Right? Just don't call it PIF without being a PIF. Exactly, Thunder Keys. I would provide printed parts for builds. I will work on becoming a dedicated PIF provider. And that way I can sell that way as well. And then, yeah, Chewy will tell you, a lot of people will tell you, because several of my printers have made it out into the wild now, that I do good builds, and I focus. If my build's going out to another person, I want to make sure it's the best that it can be. And if that means that I feel like I need to go through and reprint parts, I will go through and reprint parts. I will go through and redo the wiring just to get it up to the standard of where I think I should be at today, right? Because some of these builds have been around for a while, and they could be refreshed, right? Oh, I'm gonna say I'm not to Steve Build's level. He is anal on some things that I am not. But thank you. I mean, I've had Steve come and look at some of my builds and give me kudos, right? I built the black box. I was the first person to build a black box outside of KB3D with the regarding the kit parts, right? Other people, of course, have bought or built black box self-source, but I was the first one to do it with the kit, and Steve Builds was the next one. And there were things that he has done on his build that I've that I've had to put into mine, because it's becoming part of the newer Revs kits, basically, and the manuals and stuff. So there's stuff that he got from me. There's stuff I'm getting from him. And yeah, I mean, I kind of look up to Steve. So if you're going to put me in the same category as him, I'll take it. Humbly, I will take it. But yeah, Steve is the manual guy. Steve will come through and develop new parts. See, that's my thing. And I'll say in the black box, I have started to do that. I tend to go through and say, hey, this could be better, or order of operations. I look more at order of operations, repeatability, stuff like that, because I know my limitation is the CAD side. Now, on the black box, I have CAD'd a couple of things. Like there was going to be the side skirt blower fan, right? And the files that I initially got from KB3D, he was like, oh, hey, there's an issue. Apparently not all 120 millimeter blower fans are alike, right? So they need to be modified. I actually got those files modified for myself before I got updated files from Chris and sent him the files that I worked on, right? I also one-offed the mounts for my power supplies because I chose to go with 60-watt heaters for everything, right? I'm running 60-watt heaters on the Revo. So I'm running the Revo high flow heater blocks and 65-watt heater on my standard E3D V6 hot end. I'm drawing too much power. And like Zombie's building his with a 450 power supply. Steve didn't have issues with his because he was doing 40-watt heaters. The new build is going to be, I believe, a 450-watt power supply. In my case, I am running dual UHP 350s. So yeah, I've kind of I pushed the envelope a bit, and I needed more power because of the high watt power supplies that I'm using. Okay, we're gonna be sorry. I just realized, like, I'm sitting here doing things that you guys can't see what I'm doing. Actually, I want to go this. So we just added the rails. They're snug, but they're still loose. Like I could turn them some if I needed to. Now we're going to put in our side pieces. These are designed. There are designs for these at 2 pieces. There's also designs for all of these as a mono 1-piece unit. You would have to do that on, I believe, a 350 size printer or larger. The side panels you can do on a 300, but the front and back, if you want to do the mono pieces, you'd have to do them on a 350 size printer. Now, what you see here, basically what I'm doing is I add the part, I right click, do a modifier block. You know what? Well, I'll show you how I do these. I'll show you how I do these in just a second. So we're going to get one side slid in, then the other. Welcome on in, Free Heathen. How are you doing today, friendo? And how is Miss Beans? Is she keeping you on your toes? All of them fit on a 300 just barely? I would prefer to do these on a 350 just because getting that close to the edge, you're going to get warp more often than not. Okay, now we're going to slide in our trays. So once again, we need to pay attention to how we are, right? Okay, Thunder, here's another thing. We just slid these sides in with the fan at the top and the hub at the bottom. The very next thing says slide your trays in with the hub at the top and the fan at the bottom, which means I now need to take this whole assembly and flip it over with ends that are floppy and pieces can come out. It makes no difference. We should have had it sitting like this, then put the side pieces in. Then without having to move anything else, I can take my trays and push them in. Now your trays, basically what we're going to be doing is this slot here at each end is going into the slot in the extrusion. So with this laying flat, you should be able to push it straight back in there and it's going to line up perfectly and go right in that slot. So there's 3. Hold up this wire. And there's 4. Now there's no side slots that would fit into the side extrusions, because if you do that, now you've got either 2 different designs, or you're going to have a design where you're going to have to put some heat sets on each side, and those are very thin walls. So there would only be a couple of places that you could put heat sets. It would add too much to the complexity, and really with the way these are designed, you're not going to get any sag, right? Hey Sigarecki, how's it going? Freeheathen, how's it going today, my friend? Yeah, I just want to make sure you're both very personable and friendly and more than willing to answer. Exactly. And I try not to rant. I know Steve doesn't rant at all. He ranted, I'll say, a little bit when they bent his trident up. But yeah, for the most part, he's a very, very chill guy. And when my car blew up out in Colorado, he coordinated the rescue crew. Like, KB3D started, handed me over to Steve. Steve coordinated the rest because KB3D Chris and Chris 2 hit the road to come out and get us, right? So Steve was coordinating somebody to come and get all the printer stuff, and Chris came to get me and Evil Diesel. So just a great crew. Yeah, Saturday you're not at work, so you're going okay, great. All right, so we've now got our lanes in, and here's the real big thing. Your hub's at the back, your fan's at the back, your opening in your lanes is towards the opposite side. So this is the front, this is the back. This would be where your desiccant trays will slide in. So this is where we're going. Now we're going to take and we're going to put the front on, okay? And this has the little feet sticking up over here. Let me see if the bench side view will give that a little bit better. Yeah, it really isn't. So the front edge or the top edge is down flat on the build surface, and you'll see that the foot edge here sticks up. Why we're trying to build it here so we can make sure that our frame stays square. So we're just going to set this down. We're going to push this in, and all of our tabs should line up and go right into the extrusions here. We're just going to push it all the way back in, and then we're going to grab some more of our M5x16s, and we're going to start screwing it in. Now it says to leave one side loose. I'm just going to go ahead and snug these up until I get all 4 in, and then we'll go through and tighten the ones that it's telling us to tighten. Good morning, Jerry. How are you doing? Hope you're doing good. You're doing your best, free heathen? Good. You're tired? Yeah. I was feeling that way. I did not sleep well last night, apparently. So I got up this morning and I am in major need of the coffee. So luckily, Mrs. Dragon brought us some more coffee. So that's nice. Now, here's the one thing I will say about the new design of the skirts being thinner, which just means quicker to print and less plastic, right? Is because it doesn't have a full depth to it. Your rails, your extrusions tend to rotate on them, right? Because there's no support on the back side of that rail. So as I'm twisting this way, it wants to rotate in and twist out of a 90-degree alignment. So that's where having something that you can, I don't know, take and put along the edge there to help prevent it from rotating would be good as you snug these up. Now, I want to look, it shows this being flipped over once again. So we'll flip this over because it's showing us with the top lanes there. And shows us in this direction, and it's telling us the bottom of this side to leave loose. So we want to tighten up all of the other bolts on these sides. And once again, we're going to use our 1, 2, 3 block to make sure that we keep things square and that the extrusions don't rotate on us, but they stay nice and vertical. These ones should be good already. Yes. Okay, and lower on this side, it says to leave, or it still shows the arrow that shows leave that one loose for the time being. Not sure why, but we'll see. Once again, if we're laid like this, all the top corners are secured. The bottom corners on this side are secured. These two, loose-ish. Hey, Da Vinci, welcome on in. Oh yeah, love your maker hangout, Jerry. You're normally the one I raid into on Saturdays, and then it tends to be like Big Jano or Creatix Brit or sometimes Zombie if I'm streaming till midnight because he's the only one left on Tuesdays and Thursdays. Yeah, and I try and catch into your show, Jerry. It's just the fact that I go so long sometimes that's just I need a break, right? Move. Whoa, dang it! Stop moving that one. I want to move this window. Actually, move it over here. Probably the better place for it, so you can see me when I give my totality there. That's the frame that I'm. Hey, Bexy Beans. Twitch Dad, you're the best. You read that as Twitch Daddy. Oh my God. You guys are hilarious. Okay, so our frame is now put all together, right? So all of our trays are in. The slots, I'll say, are towards the front over here. I've got the hub, the fan and stuff facing me. So this is our box turtle frame as it stands right now. The next section was the extruders. We've already done the extruders. And then the respoolers. We've already done the respoolers. Now the next area here is coming soon. So we're kind of now off the beaten path, and we're getting back into Digital Dragon 72, aka Luke's memory for doing some of the rest of this, which is just basically plopping things in. Yeah, brain turns to mush after a while, especially if I've done like an 8 or 9 hour stream. So we're going to start by flipping this over. Yes, box turtle's on its back. I know that's bad. I apologize already. Thank you for cheering 101 bits, Liz. And Bexy Beans, thank you for gifting another tier 1 sub to Free Heathen. I appreciate that. And you resubscribed for 8 months at tier 1. Holy cow. Thank you, thank you, thank you. I appreciate that tremendously. And for those you don't, those of you that don't know, Free Heathen is another one of our makers here on Twitch. He does a lot of design work. He has a lot of his own designs that are out there. Great guy. So definitely go check him out if you get a chance. And also, we've been talking about his other half, the wonderful Miss Bexy Beans. Bexy Beans is a content creator, maker. She is a Disney princess event coordinator, as well as she makes her own costumes, does Disney princess things, and she is an event coordinator. So really, really cool. K2 Kevin, aka my bro. K2 Kevin is another awesome designer out there in the space. And he does a lot of things like the Pro Streamer collection that you can put your Elgato Stream Decks in. I will be printing one of those out soon, probably. I did some of his rugged desk organizer pieces, and I've got some of those. I need to take some pictures once I get some time with my desk again to take some pictures to put up on the socials. So, and an anonymous gifter gifted K2 Kevin a gift sub. That is awesome. And thank you for reaching out and thanking them. We're in a hype train. We're in a hype train. We're at a level 2. So thank you so much for another 10 bits there, Miss Pezliz. But does it look like a turtle? It does. And for those of you that haven't seen it yet, because we have so many box turtles, when me and Mrs. Dragon were coming back from Ohio, we came across this guy. So this is a Snoozimals box turtle. And we just thought this was so darn cute. She actually has a sloth that she's been cuddling up with a lot lately. So yeah, we went and got a box turtle. So this box turtle doesn't go on his back. He stays good. He sits over here and watches over me. And Sigareki Designs, Sigareki, I'm assuming from designs that you design stuff. If you've got a link to some of your designs, please put it out there in chat, because I honestly don't know your link. And I know that he streams on Twitch, but it's normally a lot of just the ongoing prints and stuff. So Oh yeah, Squirtle would be cool. There's somebody currently doing a full up Teenage Mutant Ninja Turtle one, themed one color wise. And I believe that's Heartcade doing it. Okay, you're formerly Mayhem 83 OG. That is correct. I do remember that now. Yeah. So we're basically, I'll say, done with the instructions. I am going to come back here to the main menu. We will grab the turtleneck when we get there. We're going to finish putting this together first, which means the best bet is to, let me think what I did. I don't think I pulled the step file down for this latest version. We'll solve that. Download. Fractal. That's what that's not what I wanted to do. Darn it. Oh. While it's doing its thing, I'm going to come over here and do I not have Fusion 360? Heck. Oh, it's under Autodesk. Tesla's just shared 2 bits. Thank you. Thank you. 20. Now you're in third place. 30, 20, 10, 10. Okay. 10 hype. Pesla's is keeping the hype going. Okay, looks like the hype train is done. We had 3 subs, 203 bits. Thank you very much, everybody. Pezliz and everybody that either gifted a sub or renewed a sub. I appreciate it very much. Need to upload a few new designs today. Okay, cool. You're waiting for TFH to leave the printer unattended so you can jump in and print girly things. Yeah, I've got a box that I need to get sent to you. I need to chat with you so I can get you a box sent. Update later. File. Open. Local. All right, Chewy, gifting 5 tier 1 gift subs. You couldn't have done that during the hype train there, bud? Just teasing you, man. Thank you very much for gifting 5 gift subs. And let's see, you gifted it to Mercurs, Sad Iron, Rob C. Quantum Assembler, Foxy Owly, and Musaka 32. Thank you so much, Chewy. Great on you. I'm going to grab my box turtle. Try and grab my box turtle if I can remember. Oh, goodness. Oh. Pretty bad when I haven't played with Fusion in a little bit, and I'm like, dur, dur, dur. We're going to hide the bottom plate here so that we can see the internals of the box turtle. And this is showing the 4 lanes all being straight. We did angle some of ours. This angling over might make it easier to get to our wiring, which, oh, you can't see what I'm doing. So let me fix that. You were busy cutting these dang heater wires. Don't cut them. So this is the underside of the box turtle. That's kind of what we're looking at here right now with the the desiccant openings down here at the bottom. So that's why we're seeing the desiccant openings. Darn it. There we go. We've got the desiccant openings, the hubs back here in the back, just like we have in the design up here. And this is basically going to tell us how to go in and mount our extruder motors here. Now, I want to see if I can't grab that screw right there, and it is the M3x8, which is what I was expecting. And because our board is going on this side, it makes it real easy. Shorter wires to longer wires. Okay? And I normally start over here and work my way over. So let me find my longest wires here. And with the way these go, the idler is now facing towards the front, and the motor is facing the left side of our screen here. So this is now going to mount like this at a slight angle. So we'll go ahead and we'll grab our M3x8 screws. And we'll start getting this put together. Uh-oh, who spilled their coffee? Bexy Beans, you're going to lurk for a little bit? Okay. Sorry about that. Kind of went way out, didn't I? All right, there we go. That mouse over there, so hopefully it stops rolling in and out on its own accord. All right, so we'll grab a couple of our M3x8s, and it's probably going to be easier to do the rear one here first. So we'll get that lined up with our heat set insert. Hey, Timor, thank you for resubscribing for 19 months in a row. Wow, awesome. You weren't twitching on the floor, were you? Well, I mean, it is Chewy. He may have forgot to turn the power off before he started cutting wires. Okay, so there's one. Now, normally what I did in the past is we had extruders that had a hole in them because they used to be a lot longer, and I would run all my wires into that cutout. But with the way we are set up now, I'm going to basically lay all of my motors in first, or my extruders in first, and then we'll come back and work on wiring. So I set this up so that the two middle ones were going straight front to back, and then the ends were angled. And I just realized I put these two ends wrong, so we will have to take some things out because I really want the end to be angled towards the hub, not away from the hub. So it really looked good when I did it. So we're going to need to take this front end off so that we can pull and swap two trays over. And I'll need to take this back off because it's going to get moved to a different position. You had to replace the heater because the wires were 1 inch short. Oh man, you know they make this thing called solder, and you can put it on metal things like wires, and you can extend them. Just throwing it out there, Chewy. You could also do like a crimped pigtail. Okay, and so once again, we're gonna slide this back off just like we did before, and we're just gonna swap these outer 2 lanes because we want them to be angling in towards the hub. Get this piece lined back up. And for those of you that have followed any of my previous builds, right, we've done a couple of them with MMBs with MOSFETi boards to run the N20 motors. The last one we built was with an AFC-Lite board, which everything is, you know, it's an all-in-one board. So you don't have to have a separate board to run the N20 motors and the respoolers, which is nice. This board or this printer is going to be using that same board. And then, yeah, so we've got plenty of step-by-step builds in my Twitch VODs and YouTube channel that, depending on if you're self-sourcing or building any other way, what is... That's nice. The hot end cooling fan speed is abnormal. I don't know why that is the case, but okay, so this is a longer wire that will go over here. So yeah, depending on how you're building your box turtle, you should have plenty of instructions out there that'll help, and that's why I'm sitting here saying, all right, now I pretty much can look at the CAD and go from here as far as how to get everything assembled, because we built 1 or 2 of these before. In fact, how many do you have built, Thunder Keys? Timor, thank you for subscribing for 19 months. Hybrid Robotics just subscribed for 13 months in a row. Thank you. I appreciate that, my friend, with your Prime sub. You certainly never done that before with a CAN bus toolhead board. What do you mean? What did I miss there? You've never done what before with a CAN bus toolhead board? Plug it into mains power and blow it up? Oh, you don't like the solder heater wires? Oh, yeah. So I just grabbed this screw, which came out of the bag of M3x8. So that's your M3x8. I'm going to say that this is an M2 by something, not what it should have been. So we'll stick that over there out of the way. You need to get a soldering and electrical kit. Yeah. I have soldered heater wires before. Um, you just have to be good in your skills. Like if you trust your skills, it's not bad. You built two and serialized the BOM parts for a third one. Need to print the trays and some of the newer parts. Okay. Cut the CAN bus wire while there was still power. Oh yeah, yeah. That's an electrifying experience. Anyone got a parts kit they want to sell? You got everything printed, just don't want to wait. I don't have a parts kit. I've got another set of frame rails. Actually, I'd have to double check. I know I have a set of frame rails. I don't know how much of the other stuff I have. Yeah, it looks like an M2 by 10. It was just weird that it made it into the M3 by 8 bucket is all. Okay, so we've got our motors now installed and they're in the appropriate order based on cable lengths, right? Now what I want to do is put in my front piece. Actually, before I put my front pieces in, I think I'm going to put in my trigger in stops. I don't want to start routing and cable managing anything because I will tend to take like, here's my lane 4 stuff. I'll add in the in stop. I'll start bringing this through, plug it into the board. And then when I start to do lane 3, I'll join it together, zip tie that all together and keep zip tying things as I'm going over. But in order to do that, I'm going to need to also get in my in stop and then my motor wire for the N20 motor so that as I'm building things over, I can be cable managing my way from lane 4 to lane 1. That there will flip this back over and we'll install the top pieces. Once again, let's look at it this way. And if you just take your motor wires, you'll see shorter wires on this side, longer wire on this side. So this is lane 4, this is lane 1. When you put in your other pieces, you're going to match it up just the same. So just going to grab a couple of these. And the way this works is you're going to take your wires, feed it into the slot, and I tend to kind of rotate it back and then rotate it forward into this front slot here. And I'm doing that because this blue jet out here goes into that extrusion lip. So by doing this, you can kind of press it down and then rotate it forward and in. There's one. We're going to do number 2 now. There we go. Then we'll do 3 and 4. And I'm not sure if it's picking up kind of the click as these things kind of fall into place, but there is a nice satisfying click as these kind of rotate down and in. Okay. And those should be relatively good as far as sticking in there. So we're going to flip these over. And what we'll be left with, and I'll try and switch back over to the overhead view. There we go. Is at each one of these positions, we'll have our set of wires coming through. And in this position, we have 3 holes. There's the center hole is a access hole to the screw that's underneath. And then these other 2 holes will be the holes that will go in that will hold that respooler motor to the lane. So we're going to need to grab some more of our M3x8s. And we'll just go through and screw these in to lock these into place. Mr. Wizix, an F. I'm not sure if you're saying that you cannot hear me. I am seeing audio, so I don't know why you would not be able to hear me. And as you can see, things are starting to get busy and messy as far as wiring goes. We will be working on that, I promise you. Because there's only so much that I can take before I start like losing it myself. Hey, Cruising Girl, welcome on in. Okay, so those are all snugged up. They're good. Our little flippers there are working good. Now, the only thing else that we need to put in here from an electrical perspective is going to be our in-stop switches. So let's kind of get those set up real fast. In-stop switches. Where was the rest of my in-stop switches? Here we go. Now, with the remaining in-stop switches, we're going to go through and we're going to look at the links, because we should have 4 separate links for our in-stops. It looks like 1, 2, 3, 4, and then there's going to be 2 that are the exact same size, and they should be 500 millimeters, and these 2 are the same size. So these are going to be for the turtleneck. So we're going to take these 2 and set them aside for now. So this will be the 4 that we're going to be using for our lanes. And once again, very simple, short wire, long wire. So short wire and short wire. Easy enough, right? We do need a couple more printed parts. We're almost out of printed parts here, so 1 second to look at this. Okay, that's not working. Stop. Yes. Sorry, folks, 1 second. I've got a nozzle blob from hell on the bamboo. So let me... whoa. Oh, yeah. Nozzle blob from hell that started to knock off the Panda. That's not good. And by Panda, I mean the Panda Jet. Or the Jet Pack. Oof. That's an issue. Wow. Yeah. That's going to be a whole new Panda Jet bottom end. Oofda. Well, that's something new that I've never had before. I guess I should have listened to it when it gave me an error earlier. Listen to your printers, folks. Bear with me momentarily while I try and get some of this cleaned up before it solidifies on. Okay. Good news is as long as I can get the fan out, I should be able to just switch it back over to the front until I get another part. Okay, so these are going to go in there. You kind of can see the design. The screw is going to go down through there, and then the end stop is going to come in from the one side here. So what we're going to do is we're going to take our end stop with the lever facing up and lay it right over that side there. And this is where we're going to need those M2 by 10 screws. M2 by 10. These are self-tappers. We'll use our 1.5 millimeter driver here. Yeah, that was an ugly blob. That one's gonna hurt. That looks like when you try to cook dinner. I don't believe you, Bexy Beans. I do not believe you. Okay. The one. Set this one up. Number 2. Now, mind you, that was definitely my own fault. I had the file that I was printing was sliced to print on a textured sheet, and I was running it on the CryoGrip Glacier Pro. So that is definitely all my fault. Just because I was too lazy and didn't want to swap a plate or reslice a file. And now I get to pay for my laziness. Funny how that happens. Oh, Lee Marie started? Okay. So if you're good with double streaming, you can jump over to Lee Marie's stream over on YouTube. They should be working on software and stuff, if I remember right. That's kind of where they're at. I think they've got the physical build done, and I don't know if they'll be pushing plastic through theirs today or not. I'm sure that Thunder may be over there helping them out as well. When you're doing these, once again, you're self-tapping into plastic. There's no need to really ugga-dugga these down. And if you do, you can split the casing on these end stops. So it's not needed. Don't do it. I might still beat them. Yeah, probably. We're going to need our M3 washers again. Oh, it's their anniversary giveaway stream. Gotcha. Gotcha. So what you're saying is bring up YouTube over here so I can enter into some of the giveaways. Because see, that's the thing that kills me. They keep doing all the giveaway streams, and I've teased them. I'm like, hey, you know, save some of the giveaways because this is like their second giveaway stream in a month. I was like, you need to save some of those giveaways for the rest of us so that we can work with people like KB3D and actually, you know, get some things to give away on our channel. You guys are taking all of the giveaways. But this is hilarious. So she's got him in a full up elf outfit and she's got like a sweater. That was awesome. That is awesome. Now, I'm just going to try and get this lined up on the heat set insert, and you've got to be careful. The motor wire comes up through a hole right about where that end stop is. So you just have to make sure that the wire for your motor's out of the way. You bring the end stop in, and then you'll start to tighten up the bolt here, and then you'll move the end stop forward. You got to be quiet and just listen for when it triggers. And that's where you want to tighten your end stop down at. Okay? And then you're going to trigger your lever. And make sure you're getting a good clicky. If you're not getting a good clicky, you're going to have issues with things triggering appropriately. So make sure you've got a good clicky noise, and then you're good. Now we'll go into the next one. We'll grab another M3x8 and a washer. And we'll get this one ready to go on. Once again, all I'm going to do first is just get my screw lined up. And then I'm going to make sure that my wire is out of the way. I'll start getting my screw close to being screwed in all the way. And then we'll move the end stop forward until we hear it click. And then we'll secure it down. And then test for clicky. And you want it, like I said, when you're moving that end stop forward, you want it to be moved forward just until you hear the trigger. Then you screw it down, because if you do it that way, you'll be good. You don't want to make it so that it has to lever out too much, because then it may not trigger on a full filament insert. So you want it to trigger just as filament's going in, and that will give you your that will give you a positive result and a repeatable result. Okay? So there we go. Coffee time. Sorry for the reach. That one's done. Finish off this one. Okay. So here's all the stuff coming from extruder 4. Here's all the wires now coming from extruder 3. Maybe we'll run them through there. Then we'll do extruder 2. Get your M3x8 ready with a washer. The washer is really critical here. If you don't use a washer, your M3x8, let me go over to what am I doing? I am at the, why am I on that one? Should be on. That one? Yeah, that'll work. If you're just using the head of the screw, as you can see, there's very little plastic that you're going to be squeezing down on. By using a washer, where the heck did that screw go? By using a washer, you're going to get a lot more surface area when you're tightening that screw down. Now, just have to try and show it that way. You'll get a lot more surface area underneath that screw head, and that's why we're using the washer on these. Gives us a lot better purchase, and it's going to hold this in place for reliability of triggering over time. Once again, I want to make sure that my N20 motor wires are out of the way. Get my end stop over there. Rotate it around so the N20 motor wires are out of the way. Move my end stop forward just until I feel it trigger or hear it trigger. And then lock it down in place. And then test it. All right, not as satisfying as I want it to be. All right, there we go. Ah! About fell over. And now the last one. And I just remembered so I just remembered that I did not rotate these wires. And remember that the in-stop wires were actually set on power and um, trigger. So what we need to do is look at our two in-stop wires, and we're going to have to depin and repin or move the pins on these, which is something I forgot to do. I should have probably just done all of them immediately. I still need to do the one for the lights, but it's only the pigtail that comes from the light over to the board that needs to be fixed. So we'll fix that one. Those two are so hilarious. I'm just making sure that all these are now pinned the same way. And once again, if they're triggering the opposite direction of what we expect them to trigger, that's easy. That's just swapping the, that's just as simple as adding an exclamation point and swapping the, we'll say the direction of the trigger. That's really not that bad. Extra early. Yeah. Yeah. Okay, Bexy Beans, tell Mom we said hi. Yeah, I really need to reach out to, I need to start reaching out to vendors now. So I'm kind of in a conundrum. So my stream anniversary, like when I started streaming, was in early January, right? Which means everybody's tapped out from Christmas time, right? Um, then my birthday is in February. So I tried to do a combined stream anniversary birthday stream last year. The problem is my birthday is February 10th, which happens to be during the Chinese Lunar New Year, and most of the companies are shut down. And they don't want to do giveaways during the shutdown because people will be like, "Hey, I'm not getting my stuff. It's slow. What's going on?" And it's just like a bad experience for people that are winning things. Which means I either need to talk to them early to get them on board with, hey, I can communicate that the delivery will be delayed slightly. That's no big deal. Or I need to possibly wait and push any stream I do until March. So I just need to figure that out. And then it used to be, though, March was hard to get people because everybody's gearing up for the show in April. But now that the show's moved till May, that might actually play to my advantage. And the show I'm talking about there is Rocky Mountain Rep Rat Festival. Okay. So one more here, and then I also want to check the rear end stop as well, because once again, all of these end stop are going to go into the same pin configuration, we'll say, on the board, and it's just currently set up that it would go into power on on one of the pins, and we do not want to send power into these. If you're doing like an opto sensor, then you would need power, but these do not need power, so okay, so those are all done. Let me check the one coming from the hub here. Yep, it's going to need to be switched over, so we'll do that. Uh-oh, somebody got a tube. That's awesome. I've got two tubes here. We're going to put one of the tubes on the Annex K3 because Hoyty was kind enough to give me a set of party plate mounting plates for it. So I can swap from the Rapido 2 to a tube. Then I'm going to put another tube on the Trident 350 that's downstairs. And that's going to be a full up, like we're going to have to take that sucker apart and do a bunch of things because we're going to do an all metal all wheel drive setup, a 9mm belt. We have a cartographer for the takeoff tool head. What else we got? We've got 9mm belt, takeoff tool head with a tube. So yeah, we're gonna have a lot of good stuff coming up. Okay, so now we've got the extruder motors in, the respoolers in, and the trigger end stops in place. Now we can start wiring things on the board. We'll come back and we'll put the PTFE tubes in a little bit. We can go ahead and start wiring things on the board and getting our wiring set up. Now, normally what I do is I would bring all the wires straight across. There will be an option to bring these wires right across between the respoolers and the extruders. We can bring them right across here. And you have two real options. You can zip tie and bundle up each individual lane, or you can kind of trunk them all together. I tend to trunk them all together. And what we're going to do, we'll get our board kind of prepped and ready. So we get our board out. And I'm not going to put the stepper motors on here yet because that just becomes more stuff that's in the way. Steppers are easy enough to just stick on after the fact. What we're going to look at is getting all of our, we'll route our cable over and get everything put in place. And I tend to start from the furthest out and work my way in so that I can zip tie it down as I go. Let me think. I'm just thinking if that's going to be the best way to go this time around. Yeah. that's what we're going to do. So I think what I'm going to start with is just putting our lights and connecting our lights together. Now, which one's in, which one's out? Let me find my pigtail for the light. It was over here. Pigtail, light. So this is the pigtail for my light. This is the female connector with the male pins. So the male connector would be the inbound side, which means this would be the outbound from this first lane. So we will connect these two together. And we'll connect these two together. And then we'll connect these two. And that'll just kind of help get these out of the way a little bit. Then we're going to take our wires from lane 4. So we'll bring all of our wires together and we'll get ready to zip tie those. Now we've got zip tie points all along our printed parts here. So we'll be able to zip tie these in numerous places along the way to keep these wires nice and tamed and neat. So we'll get one of these zip ties set up. And we're going to bring our motor around. There is a possibility of doing a zip tie on the motor right here if we wanted to. I'm not sure if we'll have enough room to do that. So we'll bring it kind of over as tight as possible here. Get our zip tie going. And once again, we've got our motor, trigger wire, our motor wire. Where I've got my motor wire. That one trigger wire, the other trigger wire, that wire. Where is my N20 motor wire there? Ah, there it is. So I didn't get this one captured in there, so I'm glad I didn't fully tighten that down. Though it is too close, I'm going to have to snip it and redo it. So yeah, make sure you get all of your wires in there when you're bundling them up. Once again, we've got our two end stops, our motor wire, our extruder motor wire. We want to make sure that for the most part they're fairly tightly run, so we have excess, if at all, over at the opposite side. Tighten that down. Now, they do not have any labels on these wires. So, I'll say somewhat unfortunately, I'm going to take these, we're going to pull all of these wires up and out of the way. Basically, I want these to go underneath all the other wires that it's going to pass by. So basically I want the lane 4 wires to be all the way down at the bottom of the stack as they come across. And that way I can go ahead and get these pinned in. So our wire diagram okay. Lane 4 is at the top left, and positive should be on the right side of the board, which it is. We need to figure out which one is the longer length for the two prep or what have you wires. So the slightly longer wire is the prep. And then the other one's going to be the TR or the load. No, let me rephrase that. It's backwards. The slightly longer wire is the load. The load is the trigger, and then the prep is the let me think that through. Load is the trigger at the front. Prep is the I'm losing it again. Trigger is prep. Trigger is the prep. Load is the extruder sensor. Okay. So prep, the one in the middle column of the 3 pins, is the one coming from the front trigger, and load is the one coming from the extruder. So yeah, that's right. Load is the one coming from the extruder. Okay, there we go. So N20 motors are over here on the right. Let me go full screen. N20 motors are the 2 pins all the way on the right. The load, the first column, the bottom 4 here, which you that camera. So these are the extruders. The hub's over here, and then these 4 are the prep. I would almost like to see these changed so that you went 4, 3, 2, 1, 4, 3, 2, 1. So prep, load, motors. So 4 was all the ones all the way across. 3 was the ones all the way across. 2 is the one all the way across. 1 is the one all the way across. And then you did your turtleneck, travel and advance at the bottom, your hub at the bottom, and you left this one open. That to me makes more sense. That to me makes more sense because that way you have a row straight across for all 3 wires for each individual lane. I could do that. That makes tremendous sense to me. I would definitely have to go and change pinouts on the AFC-Lite config file though. if I did that. But that makes a huge amount of sense to me. I'll roll with it the way it is because once again, this is a kit and I want to be, I want to follow the kit guidelines, right? But it makes a lot of sense to me to run it the way that I just described it. Okay, so there's the free motor, that, and that. So this is all the stuff for lane 3. We're going to grab another zip tie. Okay. So as we're doing these, we're cutting these and we're making sure that we're working them down through here. And the motor wire goes that way. This goes that way. And one thing I do want to do, because I'm not plugging the motor wires in just yet, I do want to mark these. That's the one I'm not actually quote unquote installing those just yet because they're going to be a little bit. So once again, lane 3 motor. And which is which? This one is the extruder, which we said is the load. Okay. So now we're going to go with lane 2. So we need to grab lane 2 stuff. So we've got the trigger or prep, the N20 motor, the extruder or load, and the motor. One, two, Kind of like a lot of wiring coming up in here. Jeremy talking about all the direct decorations he did. Really? All the decorations. Kayla did. Okay, so this is number 1. Okay. We're starting to get it there. That's all lane 1 stuff. That's lane 1, that's lane 2. Okay. This one is the one coming from the extruder. And once again, we said the extruder is the load. This is the one coming from the front, so that's the prep. And we'll have the motor wire. This is the N20 motor. Okay. And finally, we'll have the last motor and all the other skips and gubbins coming up from lane 1. Now, I'm going to leave the motors out of this next wire tie that I do down here, just because they're going to the top and it might be easier. I just realized that I am not showing you guys what I want to show you. Okay, so we're adding our wires in as we go across. Our motor wires I've tucked down over here because I want the ability to kind of go up and over. I am going to add a couple of more zip ties in here to lock these wires down a little bit more. There we go. Once again, just trying to make things nice and pretty. If I have to get in here, I'm going to regret doing all this, but oh well, such is life. I am not clamping the wires down for the LED lights. I'm just going to leave them hanging down. I don't want to stress those connections if I don't have to. There we go. You guys are over there watching Hila and them. Let me know if if my name pops up. Oh, there we go. And of course, you see me before, I normally will put some twisty, like from the Trident, the twist in wire cable ties, and I'll route my motors and stuff. So that's one of the things we could have done, was routed the motor wire and the trigger wire, brought them up and over and around. And then that way, the only thing down here in this trough would have been the lane, or the extruder load and motor wires. Possibly something we do later on. Who knows? Who knows? All right, one more zip tie right here. Okay. Use my tweezers to get that one out and around where I want it. Yeah. Under keys. Good job. Always helps if you start clean, even if you got to cut 20 zip tie. Yeah, yeah, exactly. Exactly. Okay, so we've got everything bundled coming over here from this. We still haven't done lane 1 yet. This will be lane 1 motor. This will be the lane 1 trigger, which would be over here. Lane 1 prep goes there. And then our hub most likely is going to come up. Yeah, this would be the best way for the hub to come up, probably. Would have been to come up and loop it in here. So this is might be where we go back and we cut some zip ties and redo them. And like I said, I'm definitely not at a loss for zip ties, so that's no big deal that I just had to cut a zip tie right there. That is the least of my worries. Seriously? There we go. I just brought the hub, and I want to leave a little bit of slack so it can come up between these two desiccant trays. And then we'll add it into this bundle here. And rather than undo this one, I think I'll just undo this one, add it in right here. That'll be fine. One less to pull out. And what you see me doing is being very careful so I don't cut one of these wires. And what I'm doing is I'm grabbing the head and twisting the head, not trying to cut it. If you try and cut these in place, you could very well cut one of these wires or nick it, and then you're chasing things. So we're going to try not to nick it. Now, I do believe that the final kits here are going to come with like cable identifiers for which is which. These don't have them, but no worries. I know where I'm putting things into, so we should be good. And this is the hub, which will be the bottom of the center row there. I probably should have mounted this to its plate first. And if you ever need to look at it, your silk screen is on the back of these boards. They got signal pin ground 3.3 volt all the way on the right. That's why we had to move these over. We're going to have to do our RGB, which will be an easy add-on. The fan is going to come all the way down there. We'll do that in a second. We'll plug in, like I said, our motor wires. Once we get this mounted, it'll be easier to loop those up and over. And we'll leave any of this excess just bundled up over here in the front. So we'll grab our mount. And your mount is designed in such a way, your mount's going to hang like this on the side. Okay. That allows a big cutout here for all of your switch stuff because your switch standoffs are very long. I would actually suggest trimming them down some. Be careful. Okay. And what we've got here is this switch down here should be always set to buck. So to the left facing your power cable, that is the correct way to pull power from your CAN bus. Or if you're even plugging it in and using USB, you'd plug in your USB and still run power into here because you cannot power this whole thing off 5 volt. Now this comes preloaded. You should not have to update this at all. We will build our CAN bus cable. Now I'm not going to physically mount this all the way because if we do need to get down here to use our USB, the way it's mounted, you cannot put anything in that USB if it's mounted in here. So we will kind of, we'll leave it sitting here for the time being while we verify that the board configuration is good. And then we will final mount it in the printer afterwards. But long story short, you're going to through bolt at the top and use either roll in. What they gave us? Yeah, they gave us some roll-in T-nuts. So we'll put roll-in T-nuts and mount it through the top into roll-in T-nuts. The bottom of this is going to be mounted directly through or screwed directly into the bottom of the mount. And those might be the M3 flathead set screw. I don't know. What are we using here? Makes no sense to use M3 flathead screws for this. Those are probably used. We're going to use the M3x8s. Driver. These could probably be M3 by 6s. M3 by 8s are going to stick out the back a little bit. Not too much. Maybe, yeah, M3 by 6s would be better to not have anything stick out the back. Okay. We'll have the fan. We've got the hub plugged in. We need to do our 4 motors, but we also need to put our 4 steppers in first before we do the 4 motors. So what else do we want to do? We've got the wiring there. Let's put on our feet. Put on our feet pieces before we get going too far. We can put those on now. And what we're going to have to do is we've got some accent pieces. So these go in from this side, and on the opposite side of the lip here is where the accent piece goes. And it's an M3 by 8 that goes in here. And it doesn't have to be an M3 by 8. It could be, once again, an M3 by 6. You do have to be careful. You are screwing it into plastic. And said plastic is very thin and very brittle. So if you crank down on this, once you get it started and snug, you will crack it. Because I'll get stress marks on these just from running the screws in. Once they get tight, boom, done. And once again, you're sticking way up there. That's where I'm saying M3 by 6s would be fine for these. So and all these are really kind of like alignment pieces for the bottom panel. This does not come with the bottom panel. You would have to either print it if you had a printer big enough, or have it laser cut out of acrylic, or well, laser cut or CNC'd out of like acrylic or something like that, ABS. I do have some ABS sheet. I do have some acrylic sheet, and I've got a Shapeokos. So I can cut my own if I want to go outside and sit in the cold to do it. Okay. So we've got these pieces prepped. Now what we're going to do is we're going to grab our M5 hex nuts here. And some more of our M5 by 16 screws. And we'll need the 4 feet. I didn't see the feet in here. What did I do with the feet? Because I know I printed the feet. What did I do with the feet? What did I do with my feet seat? So I know that was the first thing that I actually printed out for this was the feet. This stinks. I'm like, oh, I'm all good. I got all the printed parts. And now I can't find the one part. So I think I printed out at the very beginning. Ay, 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 ay. All right, well, I guess we're not putting feet on it right now because I can't figure out what I did with the feet. I can definitely, well, I could reprint them, except I don't have enough black to reprint them, I don't think. Do I have more black TPU in here? If I have more black TPU in here, I'll just start another print. And if I have to swap out midpoint, I'll swap out midpoint. And I don't. All right. Well, heck, I'll find them, and if I need to, I'll. Oh. Here we go. I started a bag and then put all the other parts in a different bag. So here are my TPU printed feet. I do have a little bit of stringing on the seam here. So M5 by 16 goes down in here. I've tried to do like an M5 washer in the past and it didn't work, but looks like they did provide some M5 washers, so we'll go ahead and try and do that. What the M5 washer is going to do is think like an anti-crush type of thing, so hopefully you don't crush and pull through your TPU feet. We're going to take an M5 nut and it goes in there, and we're going to use our finger to hold it in place as we get that screw started. After we put the screw through our plate, so the foot's going to be on that side where you have the lip. Your accent piece is on the other side. That little triangle cutout there is going to key into the back of the foot part on your corner bracket. And it'll line everything up nicely. And so this area keys onto the foot part, these little slits will, the corner bracket, the corner cover will slot into those to make it one piece. All right, we'll do the one on the next corner over here. And once again, I find that putting these pieces on first before you do your end caps is so much easier because you need to hold that M5 nut in place, or as Jeremy started to do, super glue it in, which is a bad idea because if you ever need to do any repair work, you're going to be hating life, especially if you super glued that in and you put the screw in before it fully sets and cures and you just super glued your screw in. TPU's been sitting out for a little bit. It's got a little bit of extra stringing and blobbiness to it. And we're just snugging these up. There's no reason to like really crank down on these corner pieces, because if you do, you're going to potentially strip out the plastic part on this side and cause that M5 nut to rotate. And there's just really no real reason to do that. Got a little blob that's right in the middle of that hole, and I can't. Let me see if I can get it with the knife. Okay. We got our feetsies on. I'm just trying to think what else we can do here before we button this up some. We've got the wiring in place. We still need to do our PTFE tubes. We need to verify our wiring and redo our pen if need be on the pigtail. This was the bad one that we replaced. TurtleNeck. All right, so I think we're pretty close. Hot end fan goes in. Motors will come up. We need to do our motors. We have this in place. Let's work on our RGB cable. So we're going to plug our RGB cable in. So you go to lock on. Ooh, interesting. That's interesting. I just noticed looking at these wires on this last one that plugs in, the way it plugs in, we're looking at red, yellow, black. When it plugs in the lock, it's black, yellow, red. So that's one issue, is the colors that connect between this pin and this pin are backwards. I have no idea how you would depin this. You swap these pins around. Is probably why they're rotating it at the JST side, because the JST side is ground, signal, red. So it's correct at the JST side, and it's wrong at, well, it's correct at the white JST connector. It's incorrect at this connector. So meaning, so the red wire is going to the red, the yellow to the yellow, the black to the black. This connector is rotated 180 degrees from where the clip is. That's why these wires, the red and the black, do not match the red and the black on its mating connector. Yeah. And I don't want to do this because these are 100% interchangeable down through here. This is the correct connector to depin and repin the outer edges. The problem is like I said, I'm not sure how to depin one of these. And hey sis, how's it going? This is a box turtle shirt. This is a box turtle shirt, and no, I'm not going to do the chicken dance. Does anybody know how to depin one of these? If not, what is this? A JST? Is that a JST like XH connector? Chewy, the problem is I don't have these crimp connectors. I don't have this crimp connector. Now, the question is, yeah, I was going to say, I think I have, because this is like, this would be like a standard LED lighting connector, right? I may have one of those. It's just not going to be black, red, and yellow. It's going to be a different color set. So, and this is what they're telling us to change, and they're telling us to change this JST because it's easy to depin. I mean, there's holes. Question is do I have anything that I can stick down into that hole that might be able to poke the pin out or depress the pin so I can pull it out? Yeah, that's what I'm thinking I might have to do is try the microfit. Let's see. Let's just take a quick gander. JSTXH. Maybe they're not JSTXH. Where was our? Yeah, I wish they called out what that other connector was. I mean, I guess it's just going to be easier to swap the pins on this. It just worries me. It does. SM maybe? Oh yeah, those are. Thank you. It is, I believe. Sorry, we just got a package in. And it is another light gray PLA Pro. That will be for some more of our rugged boxes to do the 2-color offset. I do have something else that I want to show everybody in a little bit. If I can't tell real quickly how these things depend, then I will. Yeah, that's looking like a. Push the metal prong that is visible in each pin and then pull gently. Problem is I can't tell where the metal prong is. Like if the metal prong's in the same spot, I guess I need to see. What I need to see is the actual like pin on this. The latching pin for this lower one is on the back side. I can't tell where the latching pin for this one is. Okay. We'll see if this smaller screwdriver down in there. Yeah, I just can't tell on which side of this pen I'm going to be trying to depress the locking pin on, if that makes sense. All right, so I think the easiest way right now is for me to just swap this end, which does kind of bug me a bit, but yes, this is a box turtle. We are working real hard to get this done today or very close. I know their box turtle, Jeremy and Kayla's box turtle, is mechanically built or physically built. They just have to do the software and stuff on it. Right now, I'm trying to depen. Yep, we're getting close. We're working on it. Gracious. I'm having a hard time getting this thing deep. Whoop, one side out, then I dropped it. What we're having to do is roll the red and black, which means the wires are not going to match the pinout. In other words, black is going to be going to power and red is going to be going to ground on the board. And if you were here for the L8 Stinger, you know how much I hate that. The problem is this side of the pinout was done wrong. I don't know how to get these off. There's no way to depress a pin. So the easiest method would then be to rotate these as they go into here. So ground's going to go on that side. Yeah, it just really bugs me when the color coding, especially going into the board's wrong, because I would look at that and just be like, oh, that's wrong. I need to fix that. Especially if for some reason my lights are doing something weird, I'm going to want to try and fix it. Which means then I will burn my lights out because I'll run power to the wrong side of the darn things. Okay, so that goes there. This will go here. And once again, I'm going to put this back here a little ways. And this stuff right here will just be looped out of the way. I'll probably put a zip tie on it, kind of push it up out of the way there. This will be for the fan, which will go in at the bottom. We've got our motors. Let's go ahead and get our motors. And by motors, I mean our stepper motors installed. And yeah, like I said, you might make, this is a box turtle. This is one of the LDO beta kits. Swapping out coffee. And just for those that like to hydrate, you know, we'll do some actual Evian water. What printer am I planning on running this on? We're going to run this one on Kyber Dragon right here. I do have the parts printed out to swap the stealth burner over to Filametrix. The LDO kit does come with the parts to do a Filametrix. You just need to reprint the associated parts. So we'll put a Nighthawk on this. We'll swap it over from an SB2209 to a Nighthawk. We'll wire up a Filametrix on this, and we'll get going that way. Yeah. Coffee is mostly water, yes. But it's also caffeine in it, and caffeine is a diuretic and will dehydrate you as well. And after a while, I just feel like I'm actually dehydrating. So I will tend to drink some water occasionally. All right, there's one. But yeah, I built like 5 of these. The Trident 300 over here, of course, has one. I still need, yeah, that one. That's a box turtle. This combination worked at 3D Printopia the whole weekend. This combination is currently not working just because I still need to upgrade and redo. I'm in a partial upgrade on the software here and need to reconfigure a bunch of stuff in it. The white and blue box turtle is down on the Trident 350 downstairs. That's going to move to somewhere else. It might go over to the 0G Mercury 1 Ender 5 based printer, or Ender 5 Plus based printer, because that Trident is going to go to all metal CNC all-wheel drive with 9mm belts and a takeoff tool head with a tube. And I don't know about doing a tool head cutter on that setup. I just don't know how to set that one up. And these work tremendously easier with a tool head cutter. And I pretty much have parameters dialed in for a Filametrix. So if I put a Filametrix on something, I can copy and paste things, and we all know how much I like that for repeatability. And with repeatability comes consistency, and consistency means you can use it. And in the case of my Vorons, I can take anything as size for a 300 bed and put it on any of my Voron Tridents, 2.4s, or what have you. If it's sized for the 350, of course, it can only go on the 350, but Okay. So we've got our drivers. Make sure they're going in the right direction. And we'll have our motor wires, which once again, I did not do my motor wires down all the way so that they're still easier to move around. And motor wire 1 is all the way to the left. So we should be going 1, 2, 3. And finally, motor 4. We have everything plugged into this board but the fans, and this was my concern, is with the way these motor wires are, like I don't know if these were actually designed to like I don't know how they were expecting. Like there's tie downs over here for whatchamacallit, grain relief. But then coming over here, they're a little bit tight, and it's almost like they were wired to go 4, 3, 2, 1. I know that wasn't the case. Maybe it would make sense to zip tie these down right over here in the corner, kind of get them out of the way. This would come in. These would come in. But kind of my concern is I still have to get a PTFE tube here. Then these become easy to do PTFE tubes. It's this PTFE tube here. Maybe I just leave the motor wires kind of, we'll say high. Kind of mount it just like that. Push this to the side with the PTFE tube and let these kind of come up and over. Okay. This is the fan. The fan comes around. Ah. All right, so that's in. Everything is in except for what would be the our cable for CAN bus. Kind of loop that down. This is kind of an excess. We'll loop it, try and pull it over and loop it in that way. With the rest of these end stoppy wires. Up and over, that goes there. That looks decent. Whoops. And I'm like not even showing you guys anything. So basically, I'm using my left finger here to bench side because I changed. So I'm holding my finger on a set of wires over here. This is all basically the end stop and the N20 motor wires. The actual extruder motor wires are just going to kind of come up and over. Okay. This is an extra pigtail. It just kind of sits over there. That's perfectly fine. We can even zip tie it next to the other one there. It's if we wanted to, however we wanted to run the wires basically. We need to put some mounts up here so that we can mount our board. We'll have to plug in our power here. And this would have to move way up because this is the CAN bus power. This would either have to be back here somewhere, or it would not go here if you're running desiccant trays, because that desiccant tray is going to sit down and there's no way you're going to get that plug in because it comes directly out the board. Now, if the plug was a 90 that came this way, that would be different, but he would have to re-architect the board for that. Him being Isix Tech. We can basically route the wires like this. I think that'll work. We wouldn't be able to use this desiccant tray. We could use the other three. That should be perfectly fine. 3 desiccant trays in use. I think that'll work. Let me go ahead and we'll put a couple of T-nuts in there, rolling T-nuts. And we'll use M3x10s to hold this in place. We'll work on getting these lined up appropriately once I get the board started on it. Walking the Mia. Okay, Westery. She's impotent. How's it going there, shenanigans? Hopefully you're doing good. I'm going to grab my ball end driver. It might be a little bit easier to get in here and get these lined up with where we're at. That push through. Try and line this up on the that one's lined up. If I can get these lined up and started, then I should be able to move it sideways a little bit. So both of those are in. My motor wires, like I said, are probably going to come up like this. These wires, I may add another type of zip tie over here just to keep them out of the way. There's a lot of wires coming right up here into this front edge. Like I said, I'm not sure where CAD-wise it shows this is basically being right in line with this, so maybe a little bit further forward. You gotta be careful because we do have a fan wire here that's kind of short. Right about there should be good. Looks like some wire lengths can still be optimized a bit. And one other thing, and this is, I'll say something just from, sorry, fighting with my cable. When we look at the wiring diagram, and I don't know why I didn't notice this before, it felt wonky, right? So we're starting at the bottom, and I get it that this is switch 1 through 6. So we've got switch 1 through 6, 7 through 12, right? That's the way the switches are going. And we go hub, then the prep, and the prep is the extruders, and then the load, and then we have our TN. But that means each set of these is at a different height, right? Because this is 1, 2, 3, 4. So if this is 4, why not put the load and the prep right there so that you have lane 4, prep, load, motor. Lane 3, prep, load, motor. Lane 2, prep, load, motor. Lane 1, prep, load, motor. Then put the hub down here and put your turtleneck stuff down here and one, down here at the bottom. That would make it a little bit easier, not necessarily from a wiring, but to ensure that you at least, if you do anything, you flip the prep and load wires, right? I think it would be so much easier and cleaner if you had all lanes left to right and then had your turtleneck, or maybe your hub up here in the front and then the turtleneck as the other two right back here. I think that would be the easier or the better. Though I don't know. I don't know. We're still going to have to get our turtleneck wires in here. You have two options. You can run your turtleneck, which is your buffering system wires. You can run them into the AFC-Lite board, or you can run them back into your main board. So I'm doing pretty good, shenanigans. We're just chucking along here. We've been going for about 4 hours. Just kind of working through it. We've got everything now cabled up. We'll need to build our CAN bus cable. We'll have to build our CAN bus cable down here at the bottom of the board, which is this right here at the bottom left. We'll have to build this cable. And then when we build our turtleneck, we'll connect our turtleneck in here, and then we can, do our PTFE tubes. I believe they have the PTFE tubes listed here. No. Okay, so we don't have PTFE tubes there. Do we have PTFE tube? Seeing anything? That's the wiring, print checklist. Okay. Where's the best place to go? Do these list the PTFE tube? Does not. Okay, and I know that there's a print for doing the PTFE tube lengths. So let me see what that print shows us. So this would be the print. It's got looks like 50 millimeters and 80 millimeters maybe on here. no idea. Like 80 is definitely not going to be enough. I don't know. Let's take a look and see what we got here. Let's take a look, see what we can find. Parts, PTFE sizes and lengths. There we go. Feeders to trigger, 50 millimeter. It calls for 3 millimeter inside diameter, and we need 4 of these. Now, here's what I will tell you. Feeders to triggers. Okay. Feeders to trigger, that's the little pieces that stick up at the top. The trigger to extruder is the one that comes from here into the extruder. So those need to be 80 millimeters. They're calling for those to be 3 millimeters. Here's the thing. If you make these 3 millimeters, that is such a tight 90-degree bend that every time I use the 3 millimeter inside diameter, I kink it. It does not bend gently unless you put a piece of filament in it while you're bending it. So I tend to use, I had some 2.5 millimeter that I was using, which is stuff that I got from, I believe, my Mark III kit, but I'm almost out. So I'm actually going to use 2 millimeter. Okay, I'm going to use 2 millimeter between the trigger and the extruder. And then you see it says 2 millimeter from the extruder to the outer lane, or extruder to hub for the outer lanes. And then for the inner lanes, they have different lengths. So that's where we're going to try and look at using the 2 millimeter for everything underneath. Some people might yell at me for that, but I have found that if I do 3 millimeter, like I said, it kinks, and then we have no bueno. So I'm going to use this, and I'm going to start using, 80 millimeters. So we can use our little cutting jig. Once again, the first cut line here is 50. This is 80. This would be for the vertical stubs. And then this is going to be for the front piece here. And the way we do that is we're just going to take our PTFE tube. We'll get it in our jig at the end, press it down in there, and do a straight cut right here at the 80 mark. There's one. I need 4 like this. Okay, so these are the 4 that we'll use for our inlets here, and we are going to chamfer these. We should be using, or we should be having cut filament here. So, but I do chamfer these just because I got this cool tool from Capricorn Tube to chamfer my tubes, so why not? If anybody happens to see KB3D over in Jeremy and Keela's stream, if you can tell him to jump in over here as well real fast. Because I do have a package to open up from KB3D that showed up finally. Okay, so those tubes are now nice and chamfered. We're going to plug those in, and we'll bring it over and plug it into the other side. Make sure we're nice and good in both ends. And this is where I'm saying this is a pretty tight fit and bend. It's a 90-degree bend. So doing this with a 3mm inside diameter, 4mm outer wall, it just kinks every single time on me. So I've just kind of given up on using 3mm in this area. I haven't noticed too much drag, so we should be good as far as drag stuff goes there. So yeah. So we have our front tubes. Move all of these over. I was like, why do I still have a lot of bearings? Because we have to still put these in. The rear tubes, they want it to be 2mm, so that's good. We need 2 at 85 and then 2 at 160. So we're going to have to get out our thing here and do some hand cutting. Now, normally what I would do would be, measure it out and then mark it and then cut it with my other tool so I can ensure that I get a nice, as clean as possible 90-degree angle. Especially with tube that, everybody coils up their PTFE tube, and I hate it because trying to then line it up on a measuring device and try and measure out, oh, you need 160mm. Well, that was great. It'd be a lot easier if it wasn't bent all kinds of wonky. I do use these. If you're cutting 2mm, this works great. If you're cutting 3mm, you need to use something else. Otherwise, you're going to crush your PTFE tube versus really cutting it. And you'll just run into some problems. I'm going to just kind of line these up. Mark that one. Then I'll get it set up in here and there's 2 at 160, so those should be the ends. We'll chamfer these as well. Doesn't have to be much, just a little bit. Because these should be cut ends, you're going to have a straight cut 1.75mm, and that just leads to, I'll say, a harsher ingress egress if you're not careful. So that's why I'm adding a bit of a chamfer to these. If you've got a angled cut or something, it can normally find its way in a little bit easier, but with a straight cut, if it hits a ledge, it hits a ledge. And these extruders will, I mean, push filament. Like you will push filament around if you're not careful. Or like, yeah, I think you know what I'm trying to say. Words on stream. Okay, so, and we need 85 for the inner lane. Here's one. Do you have your own printer? Yes. That was funny. Jeremy's like, yes, she has her own printer. I know it's her own printer because she yells at me when I use it. That's an indication. That is the indication that you are in trouble is when she start, you know, when your wife starts saying, stop using my printer, that means she has taken over. Okay. Now, I just did 85 and that is short. That is short. Did I cut that lower than 85? No, I did not. Okay. I'm going to cut the next ones at 100. That'll give me another 20 centimeters or 20 millimeters, which should be good. And if I need to cut the first one shorter, I will. Okay. So yeah, that 85 did not, that was too short. That might have been with, so here's the thing. I'm looking at PTFE links, most likely based off the older extruders. I don't know if these have been updated or not. So that could be an issue. And like I said, these were done at 100 now. Yeah, I think 100 is going to be the go-to on this one. I think 85 is too short. Actually, I know 85 is too short. 100 will be fine for these inner ones. '95 may actually be better, but 100 is going to work just fine. Okay, so let me throw up the overhead view right here. Okay, so we've got our 4 lanes coming down. Once again, these wires kind of tuck over here. These wires are going up and over. So there's lane 1. We've got our 4 joiners coming in. So we're good there. We've got our feet on. We've got these done. Once again, this is a dangly. This is an extra. For right now, I can just put a zip tie on that to keep it out of the way. Let me cover up the big pokey things so I don't like stab myself. So shenanigans, camera wise, the main face camera here. So this camera right here is a OBS bot. So this is the OBS bot Tiny 2. The other 2 cameras, so the bench side view here is a Brio 4K, and the overhead was a CS9 or C922. This is now the other Brio 4K. This one has given me some problems here and there, but I did drop the firmware back down and it has worked a lot more reliably since. The issue was that this camera and this side camera over here had different versions of the firmware. I never had problems with this. This camera had somehow updated one more revision. Downgrading that one, this has become a lot more reliable. And I also get better, I get a better shot because now all 3 of my cameras are 4K. So I think everything underneath here is done. We're going to throw 1 or 2 more zip ties in here just to keep some things out of the way a bit. This wire I'll be able to work to the side here once I go to put the things in. We don't have a bottom panel. We still need to build the the CAN bus cable. We don't have one of those yet. A CAN bus cable did not come in this kit. I do have another 2-wire cable. I have 0 idea what this is for. So we'll see. We'll flip this over. So what we've got is a spot to put our desiccant in. And where'd I put those? These trays right here. Nice little desiccant tray. They go in with this this little pop out here towards the front. And they just slide right down and snap in. Okay, so now I have a desiccant tray there. These 2 go in the back. This is the latch. So there's my desiccant tray. And latch. How does the latch work? Okay, we've got the latch right here. I think that's actually a print in place support that I did not snap off. So I'll snap that off. Get that print in place support off, and that makes more sense. There's our little latching mechanism. So he's just kind of pressing back and drop down. Now, I'm not going to be running desiccant in this for the near future, just because I need to I need to build the enclosure piece, which I believe what happens is we move from the printed corners to tall aluminum, or yeah, aluminum extrusion corners. So we'll see how that goes. You got to be mindful of that wire when I slip this in. Okay, so that one's there. And then this one, once again, I cannot put a desiccant tray in there because that's where my CAN bus wire comes in. So in that case, we won't do a desiccant tray, and I'll just put a lid over it. And the nice thing about that, oh, that lid's not going to lock in because it needs the desiccant tray to lock. Interesting. So we're going to have to figure something out there. If I move this forward, then I really stretch the fan cable. If I move it all the way back, then none of the other motor cables are going to connect unless I run the motors. Like the CAD shows this up here. If I slide this further back, I might be able to run these motors kind of into the back. This has plenty of length to slide this back. It would be the motors themselves not able to unless I rerouted them back around the backside here. And I can't even guarantee that that would work. So, but that's kind of where we're at. We'll figure this out. That's neither here nor there for me right now. So we've got everything pretty much physically done. We still need to put our little feeder tubes here. That should really be done with, like I said, the 3mm inside diameter tube, like that. Whoops, like this. So we'll measure out some of these. These just fit straight down in there, and we'll have a little plug top to it. These are just little guide tubes. So this part of the build is we'll say done for now. I'm not going to worry about putting corner pieces on just yet. We're going to build our turtleneck. So let me scoot this over here to the side. Stickers, and I was going to sit it there, but actually that box can go away. Let me do some cleanup real fast. So did anybody see KB3D Chris yet? That probably made a big noise and she's going to come running now. Oopsie. Okay. You haven't? Okay. So we've got two other pieces here. We've got the box turtle kit for the Filametrix and for the TN buffer and BT hard mounts. So the Filametrix is going to be for the tool head. Well, we've got the printed parts, but we're going to have to take the tool head apart. You know, we've got, what all do we have in here? We've got two D2FL switches. So these would be the switches used as the filament sensors. A couple of M3 nuts, button head screw, washers, M2 threaded flange threaded insert. Interesting. I haven't seen one of those before. Some flathead screws, some self-tapping screws, a countersunk nut, socket head screw, more socket head screws, ball bearings, steel ball bearings. These are 5.5 millimeters. That's pretty good because most of the ball bearings we were using in the box turtle kits are 5 millimeters. But all the Filametrix was 5.5 because it was built or it was originally designed to work with the IRCFA stuff. There's the little compressor spring that you're going to use. That's always nice to get. We've got our blade, be our cutting blade. Now, I wish that this was cut for us to the right length, but I'll take having a blade. Hey, look, we've got 4 5mm ball bearings as well, so they hooked us up either way. Some M3 threaded inserts. Yeah, so we're pretty good. I have no idea why we would need some roll-in T-nuts for a Filametrix. Or actually, no, I do. Because you'd have to have the side plunger that pushes on the Filametrix. So yeah, I get that now. So it looks like we have all the parts to do a Filametrix, so that's good. We've got the turtleneck here. The turtleneck we're going to work on. We will be building this right now. We'll jump back over here to the armored turtle instructions, because once again, we have a turtleneck. Now there are 2 types of turtlenecks. There's a turtleneck and a turtleneck V2. The turtleneck is the basic one, right? It's a couple of end stops right here, some ECAS fittings, and not a whole heck of a lot more. So this is the box turtle buffer hardwares, some ECAS fittings, and our D2F switch. For the bud tube, insert the bud tube from your AFC all the way through your TN as shown. No, it should stop just short. Oh, this is actually, apparently I was all the way at the end of the instructions instead of at the front. Okay, so the turtleneck. The turtleneck is a simple tool head buffer system. Let me do this. Turtleneck is a simple tool head buffer system used for syncing 2 extruder motors together. It features an end stop at each inch of the travel, advance and trailing, and these sensors are triggered 2.5mm before the hard stopping the buffer with 25mm of travel in between. Right, so it's a total of 30mm of travel, but it gives you that 2.5mm buffer on either side. Right? Yeah, I need to talk to Daniel as well, but that's a separate conversation. Part guidelines, once again, 20% infill, 0.2 layer heights, 4 for the bottom, top, and perimeters. Not your, the big thing here is not your standard Voron settings. If you use standard Voron settings, you may have fitment issues where you need to file some things down because the fit is too tight. Primary accent, part, blah, blah, standard type of stuff there. We need to put in some heat set inserts. Let me throw these, or a set of these over here just on the table. So when I flip the screen over, you guys will see the stickers that come with the kit. And bottom line, we're going to have some extra parts here because it's an LDO kit. What would an LDO kit be without extra parts, right? We need to do some heat set inserts. So I'm getting my press up here. And in our buffer hardware kit, we have some M3x8 screws, some threaded inserts, and some M2x10 self-tappers. And I will do a stream or a build. Maybe it's just be YouTube. I don't know. We'll see. On building a turtleneck V2, TurtleNeck 2, whatever. The one that uses Hall effect sensors and has like a full board to it. So we need the thicker part here. Whoops, the thicker part here. And we'll put in 4 heat set inserts. And you want to make sure that these are flush, so get them close, push them along a nice flat solid surface. Make sure that you're getting them nice and flush. And because this is a linear motion system, you want to make darn sure that you are, that your parts didn't warp. If these parts warped, reprint them. Some warp parts you can deal with. These are not them. Okay, so we've got those 4 in there. Next up, we need to get our ECAS fittings put in. So we're going to grab our ECAS 04 Bowden couplers. We should be good on our thing for now, so I'll pop that off. Put it back over there. Our ECAS, same type of thing. Nicely, they've got the blue thing already in, but I believe we need to take the black rubber piece off still. And one's going to go into our tube. You can tell that there's like a standard end here, and then a standard, I'll say a regular like tube tip here. Let's go over to this one. It might be easier. So standard like 4mm hole, and then one that's bigger. It looks like an ECAS fitting. So that's the one we're going to put an ECAS fitting in one of the ends. Love you too, my dude. Thanks, Free Heathen. Take it easy. Give hugs and kisses to your Mrs. Bexy Beans. Oh. Okay, so that one's in there. And it still does its little squishy thingy, so that's always good. The other end goes into the top here. So we'll go ahead and get this put in. That one went in a little bit easier than any of the others so far. So there you go. Next up, we need to install our 2 end stops, and I want to rotate this around so you can see how these end stops are going in. So your levers when you're installing your end stops, your levers are going the opposite directions. So opposite directions. And we're going to use our M2x10s to do these. Like I said, I've got a ton of these little bags, so I'm throwing these away. And I'm also sitting here looking at like 2 sets of rat rig hardware behind me. So we got a lot of rat rig stuff coming on as well. So I'll have way more baggies and stuff than I will need. So we can throw some away. So I'm getting one started and then the other, and that way I can kind of rotate around and find that other hole, the alignment hole, so that this goes in. And I'll say this would be the one concern I have. So there's no wire on these. So we just put these on a printed part. So we need to solder these. We'll need to solder wires and heat shrink right at the edge of an ABS part. Probably would have wanted to put some wires on these ahead of time. They haven't talked about doing any soldering of wires yet. They're just talking about physical assembly. So let me go back to the wiring diagram here and see if it talks about at all the wiring links for the TurtleNeck. TurtleNeck TN sensors 500. Wait a minute, hold on. Delay that. Here's our 500 millimeter TurtleNeck sensor wires. So these right now are extra. We do not have to use these, and we can put these back. So what I'll do is pull these self-tappers out. And I'm going to take these two and, well, I'm just going to throw them in here with the rest of mine. We'll throw these two in here. We're still going to need the self-tappers. And we got to remember that these will go in the opposite direction of each other with them opening outwards. So I was about to forget that and be like, oh, why did they make it so that we're going to have to like crimp wire or solder wires and crimp wires and stuff for this? Because I was about to not pay attention to the build. Once again, I am trying to get these lined up. Snug these, do not over tighten them. You will either strip the plastic, which would be the best of any opportunity or any issue, or you're going to crack these cases. And if you crack these cases, you're going to need those other ones and you'll be desoldering and resoldering them. So once again, the levers are facing outward here. Okay. We've got those two there. Come back to our instructions. We're going to place our ECAS fitting here. We've got one little nub there and then a horizontal nub there. That horizontal nub is going to be placed vertically. The nub that's at the end is the one that's going to go down in the slot here. So let me get this going in the right direction. And there we go. So this is what's going to move within the buffer. This little piece here is what is going to trigger the end stops. Your end stops are going to lay into this area right here. Okay. So now we're going to take this, line it up over the top, set it down on there. Why is that not lining up? I probably just had it too far over there. There we go. Okay, so just pull this around some. Now it's all nice together. We're going to put in our 4 screws. These are going to be M3 by 8s. Hybrid Robotics just won something. Hybrid. You're over in the other stream. You just won something. Go say hi. I'm not sure what you... There you go. I don't know what you won, but I just saw that your name was up there. Standard stuff here. I'm going to make sure that they're all lined up and get all 4 started. Then we'll tighten them down. And once again, just snug these up. You want to compress it, but you don't want to compress it to the point where your buffer is not moving freely, right? So your buffer should be moving freely, just like that. If it's not, you've compressed it too much. Now, the one thing that I don't like here, you've got your Armored Turtle logo, right? Armored Turtle logo. There we go. You got your Armored Turtle logo. Here is your directional arrow. Normally, the way this winds up mounting for me, I want to see this directional arrow, which means it's going to mount somehow like this. Your in feed from your box turtle comes in this way, and your out feed comes through here, goes out. So that's kind of the issue I have, is you've got this really cool logo and then you cover it up. That's my only comment about it. Okay, and what you're looking at here is filament's going this way. This is your tube that goes in and out, right? So what you're seeing is these arrows on here. Cutaway view, you're seeing the arrows on here. So we're looking at it kind of like it was cut away this way. This is your little piece that's going up and down. Your tube's coming in this way, and it goes all the way through to the end of this tube. There's a depression in there that it'll bottom out on, and then this tube will go in and just basically stop like a normal ECAS fitting. This is a push through. This will stop, and that will become your buffer right there. So these two will get, there is a spot to zip tie these here, and these wires will get brought into the box turtle and plugged in. Let's do our zip ties here. And I will tell you that I should have done this before I put these in. I'm going to snip the center pins out of here. Okay. And the reason I do that is because that's going to allow me to take my wires and kind of lay them down a little bit. And we're fighting we're trying to do strain relief here is what we're trying to do. And I want to bring both of them together in the one. Hybrid, who gave you the sub? I don't know if you got a sub to Jeremy's stream or if you're talking about a sub here. The sub here was a Prime subscription, which I don't think you can gift those. Okay, so this one gets the one, and then the next one's going to get both of them in there, which then means one will be shorter than the other. And that's an indication that that's the longer cable since they were both the same. They were both the same length. That will be the one that's, we'll say, the leading, and the longer one is the trailing. Okay. There we go. Trim these wires, or trim the zip ties. Don't trim the wires. Trim the wires, you'll have a bad day. So there's our simple box turtle buffer system. And once again, you'll take your PTFE tube from your box turtle and push it all the way through till it bottoms out. Like hold this in, push it all the way through till it bottoms out. And then you'll go in this side until it bottoms out with the tube that comes into your printer. And you'll mount this somewhere on your printer. And that's kind of where we're at that point. We've now got the box turtle. We've got this. I still have no idea what this wire is used for unless it was anticipated to be used for CAN bus. I have no idea whatsoever. Yeah, this is real simple. It's literally 2 end stops. That's it. 2 end stops and a sliding piece. This is very simple. Belay is kind of the same concept, but belay is even smaller, which means you have less distance that you're working with. So this is TurtleNeck. This is belay. Okay. So TurtleNeck, belay. You're dealing with that much distance. Where on belay, you're literally talking about the length of that tube, so like 1 centimeter worth of distance, because you're only using one end stop to trigger this. So I've built a couple of belays. I haven't installed a belay yet. I've got this installed on the 2.4 that's going to go to Evocate. So this is also going to get installed on the 2.4 behind me. Like I said, I have a couple of the TurtleNeck 2.0 boards. It's just a little bit more involved. Let's jump out to the home. So there's the TurtleNeck. We've got a TurtleNeck 2.0. So this is a tool head buffer system designed to work with the AFC Clipper add-on. It utilizes its own MCU over the USB to operate, making it a single cable addition to your Clipper machine. TN2 utilizes two Hall effect sensors to detect movement of the buffer before hitting a hard stop in either direction. Additionally on the PCB are 5 JST end-stop ports that can be utilized for filament combiners or hubs. Okay, think about that. Filament combiners or hubs. The purpose of a tool head buffer such as TN2 is to compensate for mismatched rotation distances between the tool head extruder and a direct drive AFC type 2 MMU. If you like calling them that. So same type of thing, printing stuff. You need to put some 1 millimeter felt pad here. I've got some felt that I went down and got from Walmart because my kit did not come with felt. So I had to come up with some felt. So I grabbed some felt that I'm either going to glue or most likely find some like thin double stick Scotch tape or whatever to put on there. This goes through the circuit board. Circuit board lays down in there. You'll put the, you'll secure it through. So this is going through this piece, through the circuit board into the back cover. And this kind of looks similar, familiar, right? We're creating the tube, the other end of the tube. Cover on. And this is basically that same type of tube design. It's just using magnets and Hall effect sensors to trigger it. Because these are going to be more precise and a little bit more I'll say robust, and that's why they're using it for, it's designed really for combining numerous box turtles into one, right? So you could literally have the turtleneck as your buffering system out of your box turtle. And then instead of taking it directly into a printer, you can take it into a combiner, into a TN2, and then out of your TN2 into your printer. So nothing says that you have to use one or the other. You can use them in series. It just gets more and more complicated. Okay, so we've got a box turtle built. We have a TN built. We need to run these through and plug them in. Once again, the longer cable is the first one coming in out of the turtleneck. So that would be the trailing one. Trailing and then advanced. TN2, the instructions here for the turtleneck, it did not actually say which one was trailing and which one. Yeah, it doesn't actually tell us which one's trailing and which. That would be a good thing to add some type of mark on here as to which one's trailing and which is advanced. Because are we looking at it from the aspect of the direction where this would be the input side, which would be the trailing, and then this would be the advance? Or are we looking at it from the extruder side to say which is trailing and which? Hey, Pete, welcome on in. How's it going, my friend? This wiring diagram, it doesn't really. Like, if it gave me two different sizes here, it would make sense, but it doesn't. So the only place I would be able to figure out which is which would be to look at the config if my monitor would stop flickering, where I'm going to lose my mind on. And like I said, both of these monitors that I'm looking at are the same exact monitor. One's plugged in via DisplayPort, one's plugged in via HDMI, and it's the left one that flickers. The right one has not flickered at all, and it drives me insane. So AFC Clipper add-on. Config. MCU. AFC-Lite. Not what I want. I want the AFC config. LED lights, macros. Actually, apparently it's not the AFC config. Maybe I do need the macro. Where? Macro variable. But all right. What the heck? What the heck? TurtleNeck. Advanced pen. Trailing pen. Thunder keys. Yeah, that's what I'm thinking too. Is it should match the direction of the filament. I would agree. Timor, if you're in here, you just got picked over in Lee Marie's stream. Calibrate AFC. Okay, so we'll have to get into that. Like I said, I'm just really trying to figure out now which is which. Honor is going to drive me insane. TurtleNeck buffer. Here, I'm going to go to full display, so if anything, I might be able to actually read something over here on the right if I have to. TurtleNeck style buffer. If the trailing sensor is triggered, this means that the buffer is compressed. AFC will decrease rotation distance in order to move the filament quicker to the primary extruder. The advanced sensor is triggered. Okay, yeah, so trailing, there we go. This is what I needed to see. So yes, the trailing is where the air, like the arrow is pointing towards advance. And advance would be the further one out. So that's going to be the shorter of the two cable lengths now that I have because of routing them the way I did. So that's good. So longer of my two cables would be the trailing. We're going to put a T here. And an A on the other one. A for advanced. Dang, who won a baby belt? I haven't seen you in, but I know you lurk. Won the baby belt and all. Did Timor just win a baby belt? Awesome, Timor. Yeah, I'm not sure if those have even come in on the ship yet. Okay, so we have these marks, so we can add this into our box turtle. We still need to build a CAN bus cable. And let me double check something. Did I? There's no Filametrix on this one yet, so I probably haven't done the CAN bus conversion on this one yet. And I don't think I've built a cable for it yet. What I may wind up doing I'm gonna snag the cable from, how do we do it? Let me do it. Let me do this. We're about done with the stream for today. So what we've got is we've got our, oh, got an ad break going. Whimsy Crafting. That's Whimsy Crafting. Is that Tech Jeeper or no? That's Thunder Key's wife, isn't it? Welcome back, everybody. I just realized you guys were gone in the ad. So we've got our turtleneck done. we've got our box turtle pretty much done. The only other thing we need to do is build our idler rollers, and we've got these little pieces right here. They're screws that have been made flat, so they're easy to print. And we've got 8 of these half rollers. All we're going to do is we're going to screw this into one side. We're going to grab another one, screw it on the other side. Now you've got a roller. Okay, let me go back to bench side. It'll probably be easier for you guys to see on bench side. So we're going to take one half. We're going to take one of our screw pieces. Once again, it's kind of like the D shape there, so it can print flat. Screw this into one half. Take another half. Screw that on there. And there's an idler roller. And it's sloped towards the inside, so that'll keep your filament from rolling to one side or rolling up. So we need 4 of these, so we'll just keep building these up. Okay, so we've got 4 of these done, and what we're going to do is we're going to take the remaining 8 of our MRZ bearings. There isn't much more to do, Chewy. What I have to do is software side now. And the software side, whatchamacallit. So these just pop right onto the sides here. There's your full idler. On the software side of things, the AFC-Lite board should already be flashed. It's just whether or not it will work with the latest version of software that I have on my printer. So I may have to update it. Not too bad. But the next piece that we're going to have to do is do the configs and stuff. And when I go to do that, I'm going to need a CAN bus cable connected to the board. So a couple of the things that I need to look at is what board am I running on that printer, so I know how best to build that CAN bus cable. And what I've been doing and like to do is set up a pass-through for my systems. So I will have a skirt pass-through that I'll print out. So I make the cable that goes from the box turtle and down to the skirt. So if I need to transport a printer, I can unplug from the skirt, take the box turtle off, and it's easier to move things, right? So that's what I've been kind of working around and doing. And it worked out really well when I took the Trident to, where did I take the Trident? When I took the Trident to 3D Printopia, it worked really well doing that. So I'm kind of looking at some things. I don't think this is turned on. It is not. Got a bunch of crap all over the top though. That's the part. So here's the problem we're gonna have. Okay. In order to use Filametrix on here, I need to put a plunger system so it has something to butt up against and trigger the cutter. The problem is this has carbon rods on it. So I've got to dig out the rails, which I believe are underneath this bottom shelf here, because that's a great place to put things. And I have to convert this back to extrusions. in order to put the filament cutter plunger on the extrusion, right? So we're gonna have to take this off and upgrade the or not upgrade, but put the 2.4 back to stock so that we can then do this. And really, I don't even want to say put it back to stock. What I need to do is simply get the Y side rails back to extrusions. So you just won the Hector baby belt printer. Sweet. I'm supposed to be getting one of those. I need to yell at Hector because if he's giving away and they've got them in I need to just yell at him and say like, hey, am I still getting a baby belt? Oh, Bexy Beans. So yeah. Anyhow, I'm so with that all being said, I'm kind of at a stopping point. One, as I said, I have absolutely no idea what this 2-pin wire is for. None. I have no idea. So I'm gonna have to figure out. Want to build yours? Well, like I said, I'm supposed to be getting a kit. If you would like me to build yours, Timor, I will. I'll build it and send it back to you. So I don't know what that particular wire is for. We'll figure that out. But once again, here is our box turtle in all of its glory, right? We need to add our little top pieces. I will cut those and install those a little bit later. I always wait till the end because if you ever need to flip this over, they're in the way. At least this way it sits a little bit better. And then your idlers here, they just sit down in the sides here. There are little scallops for them to sit into. They're a fairly tight fit, but they sit in there, they still rotate, so all that's good. I'm leaving this cover off partly because, well, I have to have the tray in, or the deskant tray in to even latch the cover closed, and this deskant tray cannot go in because that's right where my 4-pin cable goes into for my CAN bus. So this physically can't go in there because it's going to foul on the board. Unless I move this board forward some more, it's not going to do it. And then I may have issues with this fan, the fan wire not being long enough. So I'm going to have that. We'll have to figure that out. That ambrosia filament is Amazon. Being amazing. So both of these are ambrosia. This is the ASA Sparkle. Here, it's probably easier to see. So this is the ASA Sparkle Galactic Midnight Meteorite and the ASA Sparkle Galactic Gray. So they both have a fleck in it. So yeah, really neat. I really like the look of it. I think it really shines well and it comes out good. So I really like the color scheme here. So but yeah, Timor, if you want me to build it and send the finished product back to you, I can do that. So I think we're at a kind of a stopping point. Like about the only other thing we can do is we can take this, stick it through here and plug it into the board in the locations it's going to be. but we're still going to need to get our whatchamacallit, our CAN bus cable in, which we'll be able to stick that through. That's no problem. I can stick it through, terminate it, and add it down there. Now these are going to come up over here into the front, right underneath this fourth motor. So I can see where these plug in at. Maybe. Where am I going? I'm in the AFC Clipper add-on. I can kind of go as far as trying to install the software. The problem is once I install the software, then that printer is going to start going batty until I get the CAN bus wired in. So it's just going to be a little bit easier. Travel at the top, advance at the bottom. It's right underneath that motor. So probably going to be a little bit easier to pop a motor wire, possibly even pop the stepper motor or the stepper driver itself out. Why are these such pain in the butt sometimes? We got that out. I can get this stepper driver out. Got enough length. Yeah, whoop. Then we throw it on the ground because that's what we need to do. Travel or TR at the top, 80 or A at the bottom. So, sure. Turn, hold, connect. Make sure we don't step on our stepper driver that we dropped on the ground. Bent pins are not good. And also, hey guys, let's depin and pin these right before we blow these up as well, because these have to be depinned just like the others. Okay, we'll be able to plug this in today, or we'll get this plugged up to the board. We'll just set it in top, and then we'll come back in on the next stream and we'll start doing all of the we'll start doing all the software configuration. Once we get the 2.4 fixed up so that we can install the Filametrix on it, we can get this one up and running. Or quite honestly, if we really wanted to, we can make this work on the Trident that's already got Filametrix set up. And, you know, the configure will be basically the same on the 2.4. It's not going to be that different. Because it's still going to be, darn it, a Filametrix. this is me trying to play with a wire when it would be, I would have been done right now if I loosened the extruder motor and moved it out of my way, I'd be done by now. Okay, there's the one. The other one, we've got to depen, repen, and plug it right above that one. Okay, so that one was a little bit easier to get in. We've got that. We need to take and put our stepper driver back in. So we need to make sure we get all of our pins lined up. Yep, looks good. We'll put our motor wire back in. So now we are as connected up as we can get without physically connecting it to a printer. And like I said, in order to do that, we're going to have to do some work on the 2.4. So what I'm going to have to do is get the 2.4 pulled down and pulled over here, and we'll start working on the 2.4. And honestly, I may just do that off stream because I'm going to have to do a lot of moving stuff around over here in the corner. I'm going to have to move some stuff out because I'm pretty sure the rails that I took off of this when I put the carbon rods are down there. Heaven help me. So I'll find those. I'll bring the 2.4 over here. I'll start taking the panels off because I'm going to have to take the panels off to be able to get the gantry, because unfortunately, I don't believe I'm going to be able to basically just undo and pop one rail out and put the next rail in, or the gantry in. It's just not going to work that way. So I'm basically going to take the entire gantry apart and rebuild the gantry, and then retension all the Z-belts and all that good stuff. What I'm saying is that's not going to be an hour-long stream. But I will say 2 streams, in essence, we've got a box turtle built. So I am going to, so I've printed the parts to do LEDs and diffusers. So basically you would have your LEDs, this piece fits down in the corner. You would have the slot for your LEDs. You would have a diffuser that goes over the top of said LEDs. And then you would have the corner panel in here. In fact, I think this would go in, hold your LEDs. The corner panel basically sits over your LEDs. Darn it. And then this clips into your corner panel, and there you have your LEDs blinking on the corner panels. I'm going to reprint these solid just because I tend to do these solid. If I'm going to add any additional lights, I'll probably try and do some like back or underglow lights rather than, you know, light up the corners. It's just, it's not me. I know people like the bling. It's, I don't know, it's just not me. And then these are your little nub toppers that'll go on the little uprights right here. So I'll probably get those ready and toss them on the top here. In fact, I'm going to toss one of these into the desiccant bin. So we're good. We're ready to go. I need to modify the 2.4 and build me a CAN bus cable, or potentially, like I said, take a CAN bus cable off of like that one. Not necessarily repin it, but use it to get the length and stuff to build a CAN bus cable, and then just get it working on the Trident or something. I don't know. And I'm talking and you guys can't see what I'm doing, pointing at or anything like that. So I can basically take a cable, get a cable ready, and we can make this work over on Trident so you guys can see it working. This one is going to take a while, and I'm going to have to rebuild the entire gantry, which is another lengthy process. We also have the Trident 350 that we're going to basically do the same thing. We're going to rebuild the entire gantry to make it a all metal CNC with 9mm belts. That is a Cybor upgrade kit. So yeah, we're going to have to do some of that. We're going to have to do a teardown and rebuild of this 2.4 to make this work on that 2.4, right? The color scheme's not the exact same. It's not going to bother me. I just want, you know, can I do color prints? So, okay, everybody, but I think that's it. That's where we're going to call it a stream. We've been going for about 5.5 hours. I'm going to say let's, you know, most of you are already over there anyhow. I'm going to go ahead and stop the stream. We'll see if there's somebody that we can raid out to, but if not, I will see you guys over in Jeremy and Keela's stream, and I'll heckle them and tell them basically, hey, I caught up. But knowing that I necessarily didn't unless I put this on something. So let's see who's up and running. Jerry should be up and running. We talked to him earlier. Free Heathens online. Jerry 3DHP's online. Who does he have with him right now? Matt German. Okay, standard. The standard characters. I'll say it that way. So, Free Heathen or Jerry? You got a preference between those two? Thanks for the fun walkthrough. You secured a parts kit from Thunder Keys. There you go. There you go, Chewy. Yeah, I can print multicolor prints that match the color of the printer. Yep. Okay, folks. Yeah, unless you guys have a preference, I'm just going to probably jam over to Free Heathen, because I'm pretty sure Free Heathen will most likely jam over to Jerry if Jerry's still up and running at that point. So it'll kind of be like a two. Okay, so we're going to get the raid started. Thank you, everybody, for being here again today. I'm going to make a decision here real fast. It's probably going to just be set up to go on the Trident, and then we'll fix this one so that we can hot swap them back between the two and get them going. Thanks a lot, everybody, and have a great day. If you have any questions on the box turtle, you can go to the Discord. You can hit up my YouTube videos that are out there. You can hit me up on my Discord, or the box turtle Discord would be the best place to go, because you can get support from so many of us. So thank you very much, everybody. Have a great day. and enjoy the rest of your weekend. Bye now, everybody. And for those of you that are watching this later on YouTube, you will see right over here I believe it's right over this direction, a card for another video that YouTube algorithm feels that you might be interested in. Thank you very much. Be sure to click and subscribe and like this video. You guys have a great day.